Hello, everyone. Welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, the Associate Professor in the Department of Chemistry and Biochemistry at Florida State University. I am an expert in molecular photophysics, which is light matter interactions, particularly shining light on molecules and doing useful stuff with it. But more importantly, joining me today is Dr. Dan Hallinan. Dan, if you wouldn't mind introducing yourself.
Sure. I'm an associate professor in chemical and biomedical engineering at the FAMU FSU College of Engineering. And my research area is polymers for sustainable energy. The biggest focus in my group is batteries. So we're all about making batteries safer and longer lasting by developing new types of electrolytes. And we can get into that over the course of the night if people are interested.
So what do you typically teach?
I teach transport phenomena quite a bit, both graduate and undergraduate. I've taught some math, some differential equations, basically. We call it, we have a different name for it in our department, but it's basically differential equations. I'm teaching an elective right now, and some of my students might be joining us tonight. It's a polymer physical science and engineering.
Oh, nice.
So it's all about the physics of polymer chains.
So Dan's students, this is anonymous, so feel free to ask whatever you want. All right, equally important, Dan, what are we starting with tonight? Which game?
We are starting with Battletoads.
Battletoads, one of the all-time classic. So you are, I think, the third guest to play Battletoads on stream. Are you ready for this?
We'll see.
You have to do the pause sound too.
The pause sound?
Yeah, when it does the bass line. The beat. That one. Spectacular jam. Will this be on the test? Triboluminescence. That is actually one of your colleagues. Not in your department, but a previous guest on stream. Will this be on the test?
Nice.
We actually have a rule in our channel rules. It says no homework questions, advertisements, or spam. We're going to call that a homework question.
Nice.
All right, Battletoads. Any particular reason we chose Battletoads to start?
Yeah, so my brother and I played it as kids, and I would say it was the hardest game I've ever played, I think. At least hardest fun game I've ever played. And so, I wanted like some nostalgia and have a challenge and have some fun.
So for you video game purists, we are using Game Genie codes. He's starting with infinite lives. So you kind of have to, otherwise it'd be level one again.
That was another motivation.
Yeah.
That cheat codes were possible. I did not have a Game Genie as a kid.
Oh, you didn't?
No.
Oh, my God.
So I've never beaten Battletoads either.
I mean, we could commit. Tonight is the night. Man, it's tough, though. So I think David Collins got to the snake level. And then Rob Tomko played, and he got, I think, past the speeder bikes. So, yeah, you're in good company.
All right. Hopefully I can get past the speeder bikes. That's tough. That's like the limits of the speed with which my thumb moves.
Yeah. Well, that and just memorizing the pattern.
Yeah.
It's why, like, playing this back in the day, it was 3 lives plus, I think, 3 continues.
Yeah, that sounds right.
It's underappreciated how cutting edge this game was back in the day. It was one of the most beautiful Nintendo games.
Oops. Yeah, definitely. I agree.
All right, we're going to say Dan's sufficiently settled in. If you guys have science questions, throw them at him now before the levels get too hard.
Yeah, please.
No worries. Again, infinite lives will like it. Triboluminescence wants to know how batteries work.
How they work. Okay, that's a great question. So, batteries rely on chemical energy. They convert the energy from a chemical reaction into electricity. And what's really cool about batteries, and actually any electrochemistry, is that the chemical reaction has 2 parts, an oxidation and a reduction. In other words, one part makes electrons and one part consumes electrons. And you separate you separate those reactions in space so that the electrons actually have to flow from one, what we call electrode, to another. And obviously I can't play video games and talk very well.
Don't worry.
Yeah, so that's why you need an electrolyte. I mentioned electrolyte earlier when I was introducing myself. And the electrolyte is what separates the two electrodes, where at one electrode, electrons are generated, and another electrode, they're consumed. And so I'll tell you the full story, I guess. So another part of the reaction is ions are typically generated, and those ions need to also be conducted from one electrode to the other. And so that electrolyte in the middle, I forget how to get this one up.
I think you have to do it from the top.
I don't think I can get back up top.
No worries. You have infinite lives.
I guess I don't need it, do I?
No, it's closure. Right?
Yeah.
It harkens back to your childhood.
Yeah. So I think I finished the description of how a battery works, more or less.
Yep.
Got me.
Oof.
That hurt.
I mean, that's crazy. I mean, there's a lot of flavors of batteries, but those basic components are intrinsic to all of them, right?
Yep.
Anode, cathode, you're oxidizing at one, reducing at the other. You need to transport charge, balance it. It's just like, are you using lead acid? Are you using lithium ions? Are you using, what else is there?
Yeah, well, so there's alkaline, which are like your double A's and triple A's, and those usually have some sort of manganese type compound.
Ooh, that was nice.
Yeah, lithium ion are definitely the highest performance.
I mean, that's a relatively recent invention too.
Yes. Yeah, so there was a desire to develop lithium batteries, but one of the challenges was and still is actually that lithium metal, which would be great to use because it has such high capacity. Oh, got me. So lithium metal does not work well, and so back in 1991, I think it was, early 1990s. Oh yeah, I forgot about that. They discovered that you can also intercalate lithium ions into graphite, and so that's why we call them lithium ion batteries, because you don't want to be forming lithium metal.
That was what, last year's Nobel Prize? No, it was 2 years ago.
Yeah.
That was good enough, and yeah.
Yeah,
So-
3 scientists shared it.
So they were the first to discover lithium could intercalate, or they're the first to apply it in a battery?
They were I think both.
Okay.
The ones who won the Nobel Prize, Goodenough discovered a cathode material. So the other side
I see.
from the graphite. And I'm trying to remember the names of the other two scientists. But yeah, they all had done significant things in developing components of lithium batteries. Sony was where the graphite intercalation was discovered. Scientists at Sony.
It has changed all of our lives.
Sure
Make them
has.
smaller and more energy dense.
Yep, more portable.
All right, I will get back to the electric vehicle question, but this is a follow-up on what we were just discussing. Triboluminescence wants to know, what's so special about lithium compared to other elements?
Well, lithium, if you look at a periodic table, lithium is what, number 3 after hydrogen and helium.
Yep.
So it's very low mass. And so if you want to store so you can think about energy density. Well, really it's specific capacity, but so every lithium ion can generate or consume an electron depending on where it's reacting. And so if you care about capacity per, whoa, he's fast. capacity per mass, then lithium is going to win out because it's so light compared to other elements. Man, these infinite lives are essential.
Absolutely. I mean, there is some discussion of using like multiple redox ions, right? Like
Yes, magnesium is the one that there's been the most work on.
Uh-huh.
And the big challenge with magnesium or any multivalent ion is that you have to move it through the electrolyte. And ionic interactions are pretty strong. They're next after covalent. And so if you've got, if you have, I lost my focus.
No worries. Infinite lives.
So if you have the ions that you need to move around interacting with two different things in the electrolyte, that really slows them down. And so it's hard to transport magnesium ions. That's really the biggest challenge with all those multivalent ions.
I see. So it's larger and has higher charge density, and it's, yeah.
Yeah, so they're good in the respect that, you're moving 2 electrons. So it can be twice as heavy as lithium and still have the same specific capacity.
So is there any theoretical analysis on that? Like, what's the maximum? Like in solar cells, we have like the Shockley-Quetzler limit, right? The maximum efficiency a single junction solar cell can be. Does that exist in battery technology?
Yes. So technically, the max, the highest for so there are 2 ways to talk about it, and it depends on where you need to be applying it. And so you can talk about specific capacity or specific density. And so it depends on whether what you care about is, is volume or mass. What's more important? And actually, I heard a presentation by a scientist from GM a while back, and they were saying that it's really volume that matters more for them. So,
that's interesting.
So it being low in the periodic table is not as important then.
So I imagine that's application dependent. What are they interested in that they care about volume more than mass?
Well, just packing it into a car.
Okay. So they don't care about the mass, like increasing the energy density required.
Well, I guess to some extent they do, but like by their calculations in designing a car, it was really volume that was more so the limiting factor.
That's interesting. Oh man.
Muscle memory?
Oh man. Take him through. Did you just first try that?
Yeah.
Oh wow. That deserves a good game. Well done, sir. How long has it been since you played this?
30 years probably.
30 years and you first tried the first.
Well, maybe not 30. No. Maybe a little less than 30. Not much.
We'll say 25. Congratulations.
Thank you.
That was beautiful. Now you're going to get wrecked for like an hour. The rest
for
of it.
sure.
I played it a little bit last night just for fun. All right. Schmonite wants to know. Schmonite? I don't know how to say your name. If you could spell it out phonetically in chat, I will be happy to correct myself. But do you work with improving batteries for electric vehicles?
Yes. Yeah, that's one of the biggest motivations for couldn't get that one fast enough for advancing battery technology is that having electric vehicles that can drive further is a big desire, especially for consumers, but for the people making them too, the companies making them. So we would love to move to lithium metal if we could from that graphite I was talking about, but they form what are called dendrites when you try to recharge them. So there are what we call primary lithium batteries that you can buy off the shelf, AA size, that have lithium metal in them. And so they have huge capacity because they're lithium metal based. So discharging is not a problem. It's charging them back up that's the issue. Because that's when the dendrites form.
Yeah, I remember that early lithium batteries. They were like, don't discharge them all the way. Recharge them when you can.
That was nickel metal hydride, I think. That could, not nickel metal hydride, nickel cadmium could have the memory. So zinc actually has the same problem. So like, what do you call it? Hearing aids. batteries tend to be zinc air, and they have huge capacity too, but zinc also forms dendrites when you try to charge it.
For those not familiar, what happens when the dendrites get too long?
Oh, it shorts the cell and it causes it to discharge spontaneously and rapidly all that energy, which is a really bad thing. I forget how to do this part.
The answer is luck. Nice. Oh, you might have jumped too early. That's good though. That was beautiful.
Did I finish answering the last question?
Yes, you did. I'll keep on top of it
All right,
until I'm like 3 drinks in, then I'll forget what's going on. Luminescence. Is that a toad on a jet ski? It's a toad on a speeder bike. Oh man. Next time you're on Triboluminescence, I recommend giving Battletoads a try. Is it a toad on a jet ski? Oh, another important question. What are we drinking tonight? That is for you, Dan.
Oh, that's for me.
Yep.
We're drinking Cabernet Sauvignon.
You're the first guest that has actually requested wine.
Really?
Ask a Scientist Gaming, yeah. I'm excited. I like the diversity of drinks we go through. So, yeah, we're keeping it classy tonight, ladies and gentlemen. Look at this, glasses and everything. With the green screen.
Man, I must be like... yeah, so it's so when I committed to this, I didn't realize that today was Ash Wednesday, which is like a relatively holy day for Christians. So we're supposed to fast. So I figured I shouldn't be doing heavy drinking, but since wine is a part of our mass, our services, I figured it's a good choice.
If I say the right series of Latin words, this is an okay drink.
Well, I don't know about that. It's an okay drink anyway.
Triboluminescence has requested, take a drink. So, Triboluminescence, cheers. If you want me to reveal who you are, feel free to let me know in chat. I'm happy to tell Dan because you know each other. But orange juice, cheers. Ken, thank you for stopping by, everyone. If you have questions, yeah, Steve Leonard.
Oh, right.
Was actually on. Yeah, it's been a while, Steve. It's been 5 or 6 months. This part is hard.
Yeah, this is where the warp is, though.
Yeah, so the warp, I think it skips the next level, right?
It skips a bunch of levels.
Yeah.
Okay, I got this.
Too long, yeah. I'm booked through May. It's
there. I just missed it.
I'm excited the number of people that have said yes to coming on stream.
Yeah,
because it's a weird ask. I mean, if you randomly email someone and say, "Hey, do you want a video game and drink and talk science?" They'll think you're mildly crazy.
Yeah.
Oh, look at that! You're killing it. What level's next?
I don't know. I don't remember. Let's see.
So it's Steve that's trying to get you drunk with Take a Drink.
Oh, I got another one. Okay, I've never made it past this level.
Oh, really?
Mm-hmm.
Is this one?
Surf.
I don't remember what's on this one. All right.
There we go.
Schmonite wants to know, so if lithium has issues with dendrites, what direction should battery development for cars take?
Good question.
The billion-dollar question.
Yeah, it is. Well, I mean, so batteries like that are near and making it to market. I don't think you can even jump over these things. I think jumping is like disabled. It's rather incremental. The advances in batteries. And so they're still based on lithium ion. So there are a couple different ways you can approach it, though. When we talk about energy or energy density, there are 2 parts to it. I talked about the number of electrons that react per mass of whatever's reacting with them, or giving them up or consuming them, and then that capacity times the voltage of the battery is actually what determines how much energy there is. So you can think of it like this. If I make it to a waterfall, you can think of it as the height of the waterfall is the voltage, and the amount of water going over the waterfall is the capacity. And so the product of those two, you can see that I've never made it past this level.
No worries.
The product of those two is gives you energy. And so there's got to be something. Maybe I need to be further forward.
Oh, where they don't have time to collapse. Yeah. I think the pattern's the same every time.
There we go, forward, back. Yeah, so I guess I have made it this far before.
Because there's a warp on this level too.
Is there really? So you can try to make new cathodes, new positive materials that oh, that one doesn't move. That give you higher voltage, or you can, like with the lithium, you can try to. Oh, he got me. You can try to make higher capacity, or ideally you want to do both. You know, so, and as Ken mentioned, those multivalent ions are an interesting.
Oh, that one you went over.
Yeah, I guess because I was skipping.
Oh, you gotta hit the right rhythm.
Yeah.
Wait, sorry, multivalence.
Yeah. Right. So you're basically increasing your capacity there. I guess I need to go up top with the multivalent ions, and you can increase your voltage by like using something different on the other side of the lithium or the graphite, as are in our batteries now. My research in particular, so in order to make to prevent these dendrites from forming, you can try to make a nice stiff electrolyte. And so that's what got it.
Nice. Veteran.
What's next? Oh no. He got me.
Oh. I think you're only like 3 whirlpools away.
From the warp?
I think from the next save point.
Gotcha. Yeah, so if we can block those dendrites, then it's we don't have to worry about them forming, and we can use the lithium metal, and that would be huge, because then we could combine the lithium metal with more advanced positive electrodes that don't intercalate. So like air electrodes. Oh, but so I didn't finish answering a question about like the figure of merit you were asking me about.
Mm-hmm.
So hydrogen is really in terms of specific capacity is the ultimate. Oh, I forget what happened. Oh, they're taking my things. And so that's used in a fuel cell, which is also an electrochemical device that has electrodes and electrolyte.
Mm.
But if you can do the calculations of how much energy you can store in gasoline, in petroleum, and how much is released when you burn it, and it's like it's not achievable with any electrochemical device that you could envision. Give me my little flies. Where is he? Ooh.
Oof, that was a hit.
I don't pick him up. Oh, I died.
You know, rats fighting toads. Tale as old as time.
Where's the pizza?
Exactly. Just need some turtles and some flies, and brings me back. All right. A big spooky skeleton wants to know, maybe more of a cosmology question, why is lithium not more abundant on Earth if it's the third on the periodic table?
Yeah. So I don't know the answer to that, actually.
I know the answer if you want me to jump in.
Yeah, please do.
So it has to do with nucleosynthesis, and when you fuse nuclei together, like in the Big Bang, right? You start out with hydrogen was first, which is just protons, right? And then some of those fuse together with neutrons and you get helium. But like the fusion cycle and like the incremental steps you take when making bigger nuclei, lithium is not a very favorable element on that path. So even during the Big Bang, it's like it's hydrogen, it's helium, and then it jumps up to bigger and bigger things. So even inside of stars, like the fusion steps, it goes from hydrogen to helium to, I can't remember what it was, but like you get things like carbon and oxygen, and then you go up to iron, and that's kind of where it ends up dying. So lithium is just, it's unfavorable during nucleosynthesis. And we can make it in particle accelerators, but it is an expensive process. So yeah, I think that is a cosmology question.
There is a lot of it, or I shouldn't say a lot, but it is also in the ocean. So if we can, in very dilute amounts, and so if we can figure out a better way to capture it, man. Oh my gosh.
Squish animation, I forgot about that.
I can't beat this guy. I guess his life must reset every time I die.
And the speaking of light elements, so got the email recently about helium the supply being reduced by half. I don't know if you've seen this or if this is an issue for you.
No, not really. No, we don't really do any like super low temperature experiments.
But like NMRs, MRIs, they all use helium, and there's a shortage of helium this upcoming year. Apparently 2 plants that were producing it, one was on fire and the other one had some other issues. So
wow.
Yeah, was
that in the US?
I don't remember where it was. But there's only so many places that make helium, and they actually dig it out of the ground. And they had an issue with that, so our supply is going to be short. Yeah. So it's going to be interesting. So don't fill balloons with helium. It is too valuable to be floating stuff around at kids' birthday parties. Just saying. All right. Triboluminescence wants to know, what's your favorite electrolyte?
My favorite electrolyte? Gatorade, I guess. Gotcha.
Went the idiocracy around. I like it. Well done, sir. That's it. We're leaving it at that. That is his favorite. Although that is a UF.
I know. I hesitated, but it was.
I mean, it's become ubiquitous. It no longer belongs to them. It belongs to the world.
I mean, I would say Seminole Aid if it existed, but
there's still time. This is presumably. Well, that's interesting. Electrolyte, it just means a charged species in some medium, right?
Yeah, exactly. It's you need free ions. So the most common way to get an electrolyte is with a salt dissolved in a solvent, salt water. And actually, it doesn't even have to be I missed the jump. It doesn't even have to be a salt. It could be an acid, which gives up protons, or a base giving up hydroxyl ions. But you just need a species that dissociates into ions. That's funny.
That hitbox was weird. That didn't make sense.
Yeah, so, and it can also be, though, so there are high temperature fuel cells that only have salt in them, and it's just above the melting temperature of the salt. So it's a molten salt, and that will also function as an electrolyte. Yeah, so it's just ions around. It's just the ability to conduct ions, and it's pretty essential that. Oh yeah, that helped me. I said it's pretty essential, but I've completely blanked on what it is that's essential.
Electrolytes.
Oh, it's essential that they not conduct electrons, because you need them to pass through your external circuit from one electrode to the other in order to power whatever it is you want to power. So they have to have charge, but also not conduct. Is it going faster? Not conduct electrons. Yeah. So.
For battery applications.
For fuel, for at least for batteries and fuel cells. Correct.
So if you go the opposite way, solar cells, you want it to conduct electrons or conduct electricity. So it depends what your goal is. My personal favorite electrolyte is my bloodstream.
Nice.
because I exist because of it. But
That's good.
yeah,
I like that.
electrolytes are everywhere. Rondo's got electrolytes. It's what plants crave. If you guys haven't seen Idiocracy, I strongly recommend it.
It's pretty funny in its
Man.
absurdity.
But then it turned into a documentary, and we're all upset about that.
The documentary?
Like, it's where we are, right?
Yeah.
I mean, President Camacho. How far away were we? Really? But
place.
yeah, there's an IMDb link if anyone's interested in Idiocracy and hasn't seen it. It's definitely worth a watch. The more recent kind of version of that is Don't Look Up, the Netflix movie. I don't know if you've seen this.
Yeah. I've seen the trailer for it.
It's not as much fun because it hits too close to home.
Yeah.
Like, it feels too real. It's not an enjoyable movie, especially if you're a scientist, because it pinpoints your relatives on Facebook in a very unique way. So don't go into it thinking it's going to be a fun watch.
Feel good.
Yeah, exactly. And Nico, you're right. It's painful but spot on. Like, you should watch it, but don't enjoy it, or you won't enjoy it. But anyway, all right. An average chemist wants to know, what was your least favorite class from undergrad and why?
Oh, that would be Orgo 2.
Really?
Yeah.
Oh man, I hope Justin's not in chat.
I've told him that.
To his face.
It had nothing to do with the teacher or the material. It just had to do with, I am a chemical engineer because I like to solve problems. I like math and I like science. But also one thing I discovered, and I didn't know that this would be how chemical engineering tends to be, but it fits really well with me, is that also I didn't need to memorize much. The mantra of my professors was engineers need to know where to find the information. They don't need to memorize it. And that's not the case for Orgo 2. SN2, SN1, all that, all those different reactions that I was supposed to memorize that I was not doing a good job of memorizing.
So I will do one defense of Orgo 2. And I'm not an organic chemist. I haven't taught organic, but the reason I became a chemist was because of organic chemistry.
Really?
Yeah, that changed my perspective. But there's one profound distinction that made a difference in my professor versus others. There's a few different ways to teach organic.
Okay.
One is much more from like a synthetic perspective, where you're like, here's 100 reactions and they're useful reactions and you can memorize them and use them.
Right.
The other perspective is as a physical organic chemist,
Okay.
which is kind of more of what Justin is, or Igor Alabugin in our department.
Okay.
They're much more about, if you know that certain things, nucleophiles, like to go to electrons, all of a sudden something like SN2, regardless of the name, starts making sense. So you can understand the underlying physical
That's
phenomena.
cool.
Yeah.
I did not learn it that way.
Yeah, so if you can get that perspective on it, all of a sudden all these named reactions, they don't matter anymore because they're just abstractions of the same fundamental phenomena. And so that to me was like, and I tell this to like Gen Chem students, is this organic synthetic chemistry is the closest you'll ever get to becoming a wizard, right? In terms of like understanding and manipulating matter with how you organize things. So that's my defense of organic.
Yeah, that's cool. I kind of wish I had learned it that way.
Take Justin's class.
Yeah.
I'm guessing he teaches much more that route.
He wouldn't even know if I snuck into the back.
Exactly.
266th person in the room.
Isn't that crazy?
Yeah.
Like,
I can't
monster
imagine
classes.
teaching a class that big.
I went to a PUI where it was like, biggest class I was ever in is like 60 students.
Yeah, I did too. I assume that's primarily undergraduate institution,
Yep,
right?
yep.
Yeah, my graduating class was like 17 chemical engineers, I think.
Yeah.
There were a few more at the start, but
no, it's definitely experience. I mean, it's fun doing stadium seating sometimes. So the last day of class, the one thing I do every time I teach a big classroom is, and I saw a YouTube video on this, so I insisted I have to do it, is everyone on the count of 3 be completely silent and crack your knuckles. So you get a room of 300 people cracking their knuckles simultaneously.
Wow.
Makes the semester worth it.
is it loud?
It is. I think we have a YouTube clip on my channel. I should find that at some point. Maybe tweet it out on our Ask a Scientist. All right.
Darn.
Back to a question. Triboluminescence, I've left you hanging. Why not use hydrogen instead of lithium?
Oh, well, I mean, we have fuel cells and we have fuel cell vehicles. The challenge with hydrogen is a little bit different in that you've got to store it. It's a gas at ambient pressure and temperature. And so it's a lot. You've got, not only do you have to figure out how to store it, you also have to have safety protocols in place so that you don't get burnt by its invisible flame, because it burns invisible apparently. So like people who work at plants where hydrogen's in use or being produced or something will like walk around with a broomstick in front of them so that the broomstick gets burnt in half rather than their head, in case there's a leak with that's on fire. Now obviously gasoline is also highly flammable, and so the argument that it's too dangerous to use, I think, is not a good one. And that's why we have fuel cell vehicles, especially buses. There are a bunch of fuel cell buses, I know in California, and I think in other parts of the country now, and world for that matter. Look at his expression on the when he moves directions.
Jamming. he's having a good time.
So yeah, so hydrogen is in use too. Got lucky there.
Wow.
The game started feeling sorry for me. He's so terrible. We gotta just give him a break.
No, Nintendo has no remorse. Every one of these games is unforgiving. There's no easy setting.
I haven't used the A or B button in like 10 minutes.
No worries. All right, we have several predictions, and we haven't done any yet, so we should probably bust one of those out. If you guys aren't following, click the follow button, get your 300 standard internet units. We're about to gamble them on questions.
All right.
Science or personal questions. I think we should do this one because it's related to something we just talked about, actually.
Okay, sure.
I think this is a fun place to start.
All right.
Not science related. This is a Dan Hallinan question. What do you know about him, and what can you extrapolate to his past based on what you've known from him playing Battletoads? I'm sure this is useful. All right, we're going to pop our first prediction up there now. Again, if you're not following, click follow. Even if you're not following, spend your internet points. They're not useful for anything outside of this channel, but it is fun to guess on questions like, Daniel has a degree in chemical engineering, and so he was a double major, or a double degree.
Double degree, yeah.
Undergrad. Is his other degree in math, or is it in philosophy? Yeah, we will not reveal anything beyond that.
Yeah, I'm not going to say anything.
It's kind of fun. So when they put in their guesses here, they can bet certain amounts, so they can decide how confident am I in this answer. And so.
Oh, okay, cool.
So it's not just vote one way or the other. It's how confident are you? And so based on what you guys know of Dan and his game playing in Battletoads, was his other degree in math or philosophy? Throw your predictions in there now. You have about a minute. Yeah, so we get to watch the stats in real time. And so they actually they do a payout based on the betting ratio.
Oh, how about that? Oh, and it changes as people bet?
Yep.
Oh, nice.
Yeah. So usually there's somebody that goes underdog where if everyone's betting one way, game theory, it's worth betting the other way. If it's 100 to 1 payout, might as well.
Yeah.
All right, about 45 seconds. What do we know about Dan and his affinity for various different degrees? The answer is not organic chemistry. We learned tonight. Did not.
Yeah, sorry, Justin, if you're listening.
We'll send a YouTube clip of you shitting on organic.
I didn't. It was more my performance in it really than anything else.
Yeah. It's the instructor. It almost always is, especially in chemistry. Like there are ways you can.
I'm pretty sure I also got what you call it? Now I'm blanking.
So this might be random. It looks like it's.
It seems to change.
Yeah. All right, it has closed. Dan, what was your other degree? Chemical engineering and?
Give the answer?
Yep.
Philosophy.
Philosophy.
How did everybody do?
So here's the numbers if you want to see them. So it's 5-4 in voting, but the people that voted philosophy bet a lot more, so they got a 1.57 to 1 payout on it. So they knew you were a philosopher.
How about that?
That's fun.
Wonder what I said that gave it away.
Well, some of these questions, there's like underlying meta information. Like math is too obvious. It's probably the other one. Or is it? I don't know. You can play with their heads. But that's fun. So philosophy.
Yeah. I at one time, my like life plan was to get a degree in philosophy and be a professor in philosophy. No, that's right. It was to get a degree in chemical engineering, go make a bunch of money, and then go back to school and get a degree in philosophy and become a professor in my later life. And then I realized life is way too short to have like 2 whole careers planned for it.
Yeah.
So I was like, well, I could be a professor in chemical engineering, and then I'd like kind of get the best of everything. I went right at it.
So I guess a follow-up question on that. Is your philosophy degree useful?
Oh, absolutely. I mean, critical thinking is so essential for research and engineering and all kinds of things. And like that's the biggest thing that I took away from philosophy. I studied abroad in Australia, and took a logic course. It was a philosophy course down there, and that's a really cool logic. I don't know. Have you ever taken logic?
Like symbolic logic. And,
exactly. It's like math with letters.
Language.
Yeah.
Yep.
It's really neat. Yeah, exactly. Because and or and not mean different, very specific things.
Yeah. No, like the legalese nature of it, like your words mean things, and like I take a lot of that with me when I review papers and stuff, because there are positive claims and there are null claims and there are positive negative claims, and you know it's. And Nico says there is a philosophical air about you for sure. It's the wine. The wine gave it away. Some say science converges into philosophy.
Oh yeah, there's a cool book on that. I shouldn't have said that because now I'm sure you want to hear what the book is, and
no worries.
And I don't have the name of it, but yeah, definitely I think that in this day and age, a lot of knowledge intersects and has relevance to other fields. I mean, we see that in our research, right?
Yeah.
Interdisciplinarity, is that a word?
Oh, count it.
Is
so quoth the philosopher.
It's so essential because problems have become so complex and so hard that nobody can be an expert in all aspects of die. Well, I'll try 3 more times maybe, huh?
All right.
We want to have fun.
No, that's true. If you're not having fun, let's move on to something
Well, I'm
else.
afraid people watching me are having even less fun than I am.
We watched Jim Fadul lose to asteroids for like an hour.
Asteroids?
Yes.
I like that game.
Well, it was Space Invaders, not asteroids.
Asteroids was my favorite Atari game.
So, no, they know it's in the title. Mediocre gameplay, expert science.
Great.
If your science starts getting mediocre, we'll red flag it. But for now, we'll keep playing until you get bored.
All right. I don't want to give up yet. I've never been this far before.
The science converging on philosophy is fun because it's like I have a PhD, which is a doctorate in philosophy, right? And natural sciences fall under that umbrella because it is a logical foundation. There are rules behind the universe. We don't know what the axioms are, but we're trying to figure them out. We don't get to prove anything in the sciences like you can in philosophy because, again, you don't know the rules, but similar foundations. Fidel said, I like watching Toad go skip, skip. Then you are in the right place. Actually, if you like skip, skip, boom. There it is. Fidel, welcome. First time chat. Thank you for joining us. If you're not clicking the follow button, click that follow button. Fun factoid, we just, I think today, crossed 400 followers to the stream.
Oh,
so,
nice. Congratulations.
Yeah. So in the last month, we've crossed 2,500 unique viewers as well as 400 followers. So,
wow.
Yeah. A lot of people like watching you fail at video games. It's entertaining.
Too bad they didn't join earlier when I was kicking butt.
An average chemist, thank you for recruiting a new viewer.
What?
We appreciate it. And we have fun with it. Even if we're losing at games, we're still hanging out. We're still having fun. So
What is that sound? That sound. Oh, when you get a certain number of points, you get a 1-up.
1-up, yep.
Yeah, so that's a 1-up sound.
You know, if this is truly random, you could go down the bottom the entire time, and eventually you will beat this.
If it's truly random, you're
Yeah.
right. But I find it. Yeah.
If it works this time, I'm amazing.
You are.
Oh, it's pretty good.
Yeah, I've gotten that far. But
And Nico wants to know, what's harder, chemical engineering or Battletoads?
oh, well, that's a good question. I guess chemical engineering, because I haven't spent 15 years working on Battletoads
Yeah, I think if you committed as much time to Battletoads, you'd
as
be,
I have the chemical engineering.
yeah, you'd be a speedrunner on. I should check out what do you think the fastest Battletoads time is?
Like to beat the whole game?
Yep.
27 minutes, 13 seconds. All my internet money's on that number.
Oh man, I should have done a question. So any percent, no wrong warp. Apparently there's a glitch you can do to warp to the wrong location, but going through, you only using the warps built into the game.
Okay.
12 minutes and 33 seconds.
Wow.
That is legit.
But still, that's like 12 minutes of flawlessness.
Yeah, no, they're going to be amazing. So even if you play every single level and beat every aspect of the game, it's 28 minutes.
28.
Yep.
So the 12 is with warping.
Yep. Yeah, that's with the warps that you took. Apparently there's a way to, I don't know how they do the wrong warp version of this, but apparently you can get to the credits in 3 minutes and 9 seconds. So that's probably harder than chemical engineering. All right. Oh, Triboluminescence, I missed your philosophy question. Can we know if something's true?
Can we know if something's true?
Yeah, no, sip wine before answering this question.
Okay. Good idea.
We're getting all epistemological up in here. Ask a philosopher gaming.
Can we know if something's
is
true? Well, I guess first, the question really is, can we know?
Oof, throwing it back at you, Triboluminescence.
Yeah, so that would have to be established that we can know anything. And then we could try to tackle, can we know if something's true? I mean, we can know if something's sound.
That's fun. What kind of hitbox is that? Like, that was not a hit as far as I'm concerned.
It knew I was, like, my hand was off the arrows. I wasn't paying attention. The auto drive was yelling at me.
Yeah.
So do you want me to keep going on?
Yeah, might as well.
Okay. Yeah, so I can know that this level is really hard. So we can know if an argument is sound, but the argument being true requires that the premises are true. And whoa, he didn't die right away. And so then, can we know that the premises are true? I mean, well, I think there are some things we can know that are true. Like, 1 + 1 = 2. I think we know that's true, right?
I think, therefore I am. Who's that?
That is Descartes. Yep,
Yeah.
very good.
Yeah. I think, therefore I am.
Jeez, that one
But
gets.
that's all you know. Is that you exist.
Yep. Well, then I had this really cool old philosophy professor, and I don't even, maybe it was epistemology was the course, but we went through the different, like, it was kind of historical arguments for the existence, for and against the existence of God. And the one that, and like, what it really comes down to is you can't prove it 100%. But the term that got closest, which was pretty cool, is that than which nothing greater can be known.
That's what it reduces to.
Yeah.
Wow. That's fun. So did you ever get far enough in philosophy where you started doing like Gödel's incompleteness theorem and like...
Sorry, say it again. What?
Gödel's incompleteness theorem and like Hofstadter and I am a strange loop and that like...
No.
I mean, it's all...
No, I don't recall any of that.
I don't even think that's formalized in undergrad philosophy classes. But I had a buddy that was doing like a master's and a PhD. And it was
in philosophy.
Yeah. And that's a route to go. That's an interesting choice. Triboluminescence has solved it. I doubt, therefore I think. Therefore I am, I think.
That's funny.
We've gone too far, ladies and gentlemen. All right, anyone just joining us? Ask a Scientist Gaming, mediocre gameplay, expert level science, mediocre philosophy. We'll add that on the list. My guest today is Dr. Dan Hallinan. He's a chemical engineer. Particularly, he's interested in polymer engineering for sustainability, things like CO2 capture or ion transport in batteries or membranes for desalination. Desalination is how I say it. I think it depends on which continent you're on. Yeah.
How to say it, but
yeah, if you have any questions for Dan, throw those in chat. I suppose I should change the title a little bit. So we have polymer engineering, ion transport, and batteries. You want me to change it to a different topic? Just leave it as that.
It's okay, I think.
Yeah. So there's So part of Twitch, I don't know how familiar you are with it.
Not at all.
There's a bunch of different categories that you can stream under. Like you can stream under a specific game. So if somebody searches Battletoads, we'd be on the list of people playing Battletoads.
Oh, cool.
There's also just chatting, which is just people like podcasts or conversationally playing. There's like arts and crafts. There's science and technology. There's all sorts of things. So it's very different than just video games.
Gotcha.
But one of the things I wrestle with is what category do we fall under? Because I wouldn't put us under video games necessarily.
Yeah, I mean, if somebody came here to watch Battletoads being played, I think they'd be pretty sorely disappointed.
Oh man, just screaming at the screen. Just
what are you doing?
I'm just waiting for somebody. Retro is one of the larger categories. Just chatting is pretty huge too. Isn't there? They added a like hot tub category.
Hot tub?
Yeah. So there's this weird transition where a whole lot of people started like wearing revealing clothing and stuff like that, and all of a sudden it became 18+ type streaming. So they added a new category rather than banning it because they're trying to compete. Just chatting science retro. I'll add retro to that.
I hit that one every time.
One day they will recognize your new category too. Yes. Ask a blank. We're the only ones there. I like it. All right. Steele's lunch. You got a big one here.
Steele's lunch?
Yep. I like to think that each field of science is a collection of correlations and trends of science below it. Like psychology is based on biological trends, biology is based on chemical trends, chemistry is based on quantum physics, and so on. Based on this, would you say philosophy is the smallest or the largest science?
Oof. Smallest or like at the bottom or the top?
Yep.
Like the toes or the hair of the giant whose shoulders we stand on? I would say that, if you look historically, philosophy was what science developed from. What was that thing? So in terms of there's definitely not a chicken and egg problem. Philosophy came first. I think that, So in that sense, I guess I would put it down at the toes, at the bottom. Am I using the right terminology? Does that make sense?
Yeah.
Based on the question.
I'm following it. So I remember there used to be in earlier Wikipedia. This had to be 15 years ago. If you would click the first word, start on any Wikipedia page and click the first word over and over again, it would take you to natural philosophy. That would be the bottom of Wikipedia would be natural philosophy.
Yeah, or art, I think.
Yeah.
You could end up at art, right? Because I think I think art is another one. I think there's more than one. or at least there was at the
Depends
time.
what branching ratio.
I
yeah.
wasted time clicking that many times. Did it once.
Early Wikipedia was awesome. There was a game where it was like, it would start you on a random page and said you have to click links until you get to another page. Did you ever play that? It was like it was a race. So it would start people out in groups. There'd be like 30 of you and say, here's your random page, find X, Y, or Z.
But you had to click. You couldn't type or search.
You had to click.
Wow.
So it was through links. And so, yeah, you had to get really creative. It's like multi-level, I don't know, Jeopardy kind of. You have to have insights into every page you're on. So that's pretty fun.
Yeah.
But I'd agree that philosophy is like the most smallest science, or the foundation of all of it, which is why we're a doctor of philosophy. We fall under that umbrella. Right. So that's really fun.
Yeah, nice question. Thanks.
Aaliyah, welcome to the stream. Thank you for first-time chatter / viewer. Click the follow button if you're not. Enjoy your standard internet units. We will gamble on other things about science and a little bit about Dan. But the question Kalia has for you is, what's your favorite fun fact in any category?
Yeah, in any category.
Any category.
Oh, well, I have a fun fact in polymers prepared, but in any category, wow. Let me think about that for a minute, because that's a fun question.
I'll fill the time with my fun fact or favorite fact of the week.
Okay.
So just this last week, so Super Mario Brothers, the original Mario Brothers, is like one of the most optimized speedruns that exists. Like, people have done it so fast. So there's a computer-generated speedrun that does it perfectly, right?
Okay.
Like, it does it as fast as it can.
Yeah.
Humans are now 3-segmenting a perfect Mario run. And so what that means is if you splice together the 3 best runs from humans, they have regenerated a computer-perfect run of Super Mario Brothers. And so that's just in the last year and a half. It's gone down from like 10 segments down to 3.
Wow.
And so theoretically, humans will come across the perfect Mario run sometime in the next, we'll say, decade or so.
Well, monkeys with typewriters, right?
Yeah, in this case, it's monkeys on Twitch with controllers, and we're doing it, which is kind of crazy. All right, so your factoid.
Yeah, so my factoid. Let's see.
Steele's Lunch has redeemed take a drink. So before your factoid, cheers, Dan. Thank you for joining me. I
my
appreciate
pleasure.
it.
This is fun.
Is it though?
Well, there's a pause button that I didn't bother to hit, and I probably should have, but I think the pressure is kind of off when you have infinite lives.
No, that's true. Like, it's not as stressful, which is good because we're drinking and sciencing.
Yes. So, well, I'm going to give you my polymer one because I didn't think of anything better in the time I had because I was actually listening to what Ken was saying.
No worries.
But so cross-linked polymers are
It's good.
So networks. So let me. I guess I need to give a little bit of background before I give the factoid. So a polymer is a very large, high molecular weight molecule, and often, in simplest terms, it's very long chain. But we can actually take those long chains and connect them together to form cross-linked networks. And a highly cross-linked network, an example of one is a car tire. And a car tire is so highly cross-linked that it's essentially one giant molecule. I like that factoid. I think that's pretty remarkable. So molecule you can hold in your hand, hold in your arms.
Yeah. So Justin used a similar for one of his predictions about bowling ball, which is the same general phenomena, right?
Yeah.
But the crosslink, is it the sulfur in that, the vulcanized?
Correct. Yeah,
that's what makes it so.
Yeah, that's one. I mean, they've really optimized tires these days. And here's an interesting fact. I'm about to get a plug-in hybrid vehicle, but
awesome.
I've had a Hyundai Elantra since 2004, and I've been keeping my fuel efficiency records on it the entire time I've owned it. And when I
was that the final jump?
I don't know, but that's the farthest I've ever made it.
That was beautiful.
When I got new tires, I got low roll resistance tires, which apparently they're basically just softer sidewalls. And so less energy is lost in like deforming the tire at the bottom where it goes flat. And my fuel, and I had lost some, miles per gallon as the car got older. But I gained somewhere between 3 and 5 miles per gallon from my low roll resistance tires.
Wow.
Yeah, I couldn't believe it was that much. It blew me away.
That's pretty amazing. Ninja Physics, welcome back. Always a pleasure to have you. Guest today, anyone that's just joining us, is Dr. Dan Hallinan, an expert in polymer engineering, particularly for application in batteries or CO2 sequestering. I don't even know if that's the right word.
Well, CO2 capture.
Yeah,
sequester. Then
minerals.
You use it for something. Yeah.
But if you guys have questions, throw them in chat. Cuddle Puppy wants to know: do you lose any traction with those tires?
No, not at all. No, so it's only the resistance to it going from being round to flat as it comes in contact with the ground, but the actual static resistance, the traction is the same. So no, you don't sacrifice any traction. But if you hit a curb too hard, you can pop the tire. Apparently, that was one of the reviews I saw. I haven't done that lately.
Thankfully.
But the sidewalls are softer.
Man, I don't know. When you see, you go on Amazon and you see the 1-star review where somebody did something to wreck something, you're like, what are the odds of that? What? How fast were they going at that curb? What was the circumstance? How square was that curb?
I always take note of how many spelling mistakes there are in a highly negative review, because that's how because otherwise it's how do you know whether how do you know whether to trust it or not? I mean, that's one somewhat objective way.
Cuddle Puppy is upset. I guess I can't use them because I drift in residential neighborhoods. To each his own, Cuddle Puppy. Sacrificing fuel efficiency. Hamsterlicious, thank you for the tier 3 sub for Ninja Physics. We always appreciate you guys. Don't have to help support us via subscriptions, but we appreciate it. It pays for alcohol and keeps us in this habit. So we do appreciate your support. If you guys are going to subscribe, I recommend using Amazon Prime because that's free to you. If you have an Amazon Prime account, attach it to Twitch subscribe with that, and it comes out of Jeff Bezos' pocket instead of yours. Save your money. We don't need it. We're doing this for fun. It's voluntary. But again, we appreciate it when you guys do subscribe. So thank you as always. But if you have questions, throw them in chat. We are happy to talk more. Fidel wants to know, what led you to study polymers?
Well, so when I was a senior in undergrad, I learned about hydrogen. I learned that there were ways to store and generate energy that don't rely on gasoline. And being from a really rural part of Pennsylvania and having a lot of time in the natural world and appreciating trees and all things natural, really, I sort of recognized early in my life the need for more sustainable energy. And so when I learned about hydrogen and fuel cells my senior year of undergrad from Professor Javad Tavakoli at Lafayette College, little shout out.
You should send him this YouTube clip.
Yeah.
No, for real though, if you guys have a professor that changed your life, send him a note, send him a message, because we deal with a lot of shitty students, but once in a while you get one that does something awesome.
So he introduced me to fuel cells, and but I didn't know much about fuel cells at the time, and I was pretty immature actually leaving undergrad. So I took some time off and kind of like this toad here, learned to surf. But then eventually I knew I wanted to go back to school. I wanted to do something to... Hold on, I can't talk.
Don't worry. Holy shit. Just, oh, come on. That was so close.
All right. Yeah, so my friend Mike Ermold was in grad school at Drexel University, and he said, hey, there's a seminar on fuel cells. I know you're into fuel cells, and I've been trying to get a job in fuel cells. But it was at a time, it was like 2000. not 2000. It was like 2004, 2005, early 2000s, and like all the fuel cell companies were actually laying people off. So I went to this seminar, and it was a guy from WL Gore, and afterwards I went up to talk to him, and I said, "Are you guys hiring?" And he said, "No, I'm not hiring, but you should talk to this guy who invited me here." And his name's Professor Joe Elabd, and he was studying fuel cells at Drexel. And I had actually already taken the GREs because I thought about grad school and whatnot. And so then and there, he like took me to the main office and had me fill out the paperwork to go to grad school. And so I knew nothing about polymers until I started graduate school. And I learned all about them because it's an essential component of fuel cells. So it was all about sustainable energy led me to polymers. It wasn't like I wanted to find a way to use polymers. Sorry, I had to pause there.
Yeah.
But yeah, so polymers are amazing materials. There are lots of amazing materials, but that's what I've become expert in, and it's because they're essential for a lot of sustainable energy applications, including fuel cells and batteries.
It's underappreciated. Of the last 100 years or so, it's probably had the greatest impact across the most things, from medicine to machinery to everything. Like, it is crazy how much it's impacted us.
Yeah.
All right. Hamsterlicious, thank you for the Amazon Prime sub. Yes, repurpose Jeff Bezos' money. We appreciate it. It's such a so Amazon owns Twitch.
Oh, really?
So it's part of their network of things. And so yeah, they have there's a Prime account you can attach to your Twitch and subscribe with it. So yeah, it's really cool. It works that way. But yeah, Ninja Physics, love giving, receiving shout out to teachers. Absolutely. I mean, even if you haven't talked to them in 30 years, that email can make their day. It's pretty awesome receiving one of those random messages saying, "Hey, just wanted to let you know I got a job here and here and here, and I use this and this and this every day." It is such a satisfying feeling. Definitely. Even if 1 out of 300 students sends that message every 2 years, it makes my day. All right. Two Stings, thank you for the follow again. Welcome to Ask a Scientist Gaming. If you have questions, throw those in chat. We are happy to answer those questions, particularly related to polymer engineering, battery technology, CO2 capture, desalinization. It is totally up to you guys what we talk about tonight.
Yeah.
All right. Ninja Physics wants to know, Dr. Hallinan, what is your sense of our progress in the commercial market versus where we know the science for fuel cells can meet our needs?
Well, in terms of fuel cells, they're pretty well. So there are a few different types of fuel cells. First of all, I guess I should tell you, there are high temperature fuel cells that are used for stationary power. I was talking about earlier when we were talking about different types of electrolytes. They're high temperature so that the salt is molten, and they work quite well for stationary power. And that's sort of the two big delineations when you talk about energy storage, or technically fuel cells are energy conversion, but similar to batteries. So conversion or storage, it's whether you are trying to solve a stationary problem, like you want to put it at the bottom of a wind turbine, or at a solar farm, or you want it to be portable and stick it in a car, or stick it in a laptop or a cell phone or something. So those solutions can look very different. High temperature fuel cells are pretty well commercialized. Actually, low temperature fuel cells for transportation are also pretty well commercialized. And those run on hydrogen, the hydrogen we were talking about earlier. They're often called proton exchange membrane fuel cells, or PEM fuel cells. And they are more so used, and I guess it's maybe because of practical challenges of storing hydrogen in compressed tanks. It's easier to figure that out in large vehicles like buses. Yeah, so the research as it stands for fuel cells is not so much, there's not all that much really left to do on the polymer side. I mean, I guess if you could make a less expensive polyelectrolyte membrane for fuel cells, that would be desirable. But that's really just a cost thing, not so much a performance thing. And again, I mean, sometimes cost is really important and drives. Just go down there. And drives things. And so the one place where there is still a good bit of work is actually in catalysis for fuel cells, because at least for the hydrogen ones, they use platinum. And anybody who has shopped jewelry knows that platinum is extremely expensive. So finding either a new catalyst that can a catalyst is something you add in order to make a reaction happen either faster or more easily, so either finding something other than platinum that you can replace it with, or finding ways to distribute the platinum in very, very tiny particles, well distributed, so that you need a very small amount of it, or sort of where there's still some significant research going on in fuel cells.
Steals lunch. Congratulations on your high score. You have peaked out.
I saw that. That's kind of wild, huh?
Congratulations. Even if you don't beat Battletoads, you still got the high score. All right. This is a fun comment from Hamsterlicious following up on the shout out to teachers. I've emailed and Facebook messaged my high school English teacher. She never responded and left me on read.
Well, maybe this is the wrong email address.
Yeah, benefit of the doubt to your high school professor. That's awesome. All right, we should do another prediction.
Okay,
we should decide if you want to keep playing this or not.
I very soon, if I don't make it through this time, I want to.
Well, let's do a prediction while you're playing this.
Okay,
We should
sounds
probably get rid of some of these guys. Battletoads is the catalyst for rage. Absolutely. There's your Aaron Vanucci rage emote. See, man, the speedrunners in this game have a different level of dedication.
I mean,
for sure.
how? It's what I want to know.
I don't know, the 3-minute one, I'm sure there's some way to like clip off the screen and you warp through levels, and it's crazy.
Oh yeah, you like drop off the side or something.
Yep. You hit the jump right and it does something crazy, and yep. That is the nature of speedrunning. All right, which prediction should we do?
Let's do either. I was just thinking of one. Let's do either this one or. Oh yeah, that's a good one.
Relevant.
Yeah, that's a fun one.
Okay. All right, ladies and gentlemen, we're going to throw a prediction up there. Have your standard internet units ready to spend on a question. If you're not following us, click the follow button. You can use your 300 standard internet units to gamble on this and make us drink alcohol, which is kind of fun for everyone involved. We're going to throw a prediction up there right now. The question is, what is the difference between trash bag and battery separator? I mean, they're both a plastic, they're both a polymer. The question is, what's the difference? Is it the polymer type or the porosity, or the holes in it, if you want to simplify it? Porosity is acceptable.
Absolutely.
I'll change that on.
Yeah, absolutely. It's just a more technical term.
Yeah. So is it a different polymer, or is it just the porosity of the polymer that dictates that? All right.
Oh wow! I hit the very first one.
It's time to call it quits.
Yep. Hit the very first one. Okay.
I should clip together a highlight reel of you hitting every single one. It's just like 3 minutes of, or cut it to a song or something. Get it to the Battletoads beat.
That would.
Someone else do that. I don't have the skill set.
He hit all of them. How did he find them all?
Have you ever seen the machine learning algorithms playing like old video games where there's like 1 million of them starting out and most of them die right away, but some make it beyond? We could do that with Battletoads, I'm sure. Low light reel. Absolutely. All right. You guys have about 45 seconds. The question is, what's the difference between trash bag and battery separator polymers? Is it the polymer type, or is it the porosity of those polymers? Which one is it? Dan has his last hurrah.
Yeah. We're switching games as soon as.
Trick question. Both are defined by the wave function of the toads bouncing through the river of life. I'm sure this is a metaphor for something. your students will learn from this somehow. All right, so time is up. The question is, what's the difference between a trash bag and a battery separator? Polymer type or porosity?
It is the porosity. Trash bags are made of polyethylene, and lithium-ion battery separators are also made of polyethylene. The only difference is they take that thin sheet of polyethylene, and they stretch it. And they stretch it so far that it develops pores, and you need those pores because you need the ions to be able to get through. So unlike the polymers that we study in my group, where the polymer itself can dissolve salts and conduct salts, the polyethylene does not dissolve salts, and it just acts, it's just a separator. It is not an electrolyte. So there's a liquid electrolyte in lithium-ion batteries, and it's an organic solvent with salt dissolved in it. And I died. And so you need the holes so that the ions can get from one electrode to the other.
Is it not crazy that polyethylene is still the answer for so many things? Yeah. I mean, it shouldn't be, right? It was an early polymer, right?
I think one of the earliest synthetic polymers was nylon. Mm-hmm. I think during World War II, because of natural rubber became limited. Mm-hmm. Polyethylene was, and Justin could really talk about this at great length, but or Dr. Rufina Alamo in my department. But the catalysts, I mentioned catalysts earlier, the catalysts to get ethylene to react were really essential in being able to make polyethylene, which is now the in terms of pounds or tons really produced per year, it's the largest by far. I mean, like polyolefins, polyethylene, and very similar polymers are something like 90% of all polymers produced. I think it's that high. I think it's like, they dominate all other specialty polymers, and so I'm ready to switch games.
All right, what do you want to go to? We have Tecmo Bowl, ice hockey, Mario Kart.
Let's do some Mario Kart.
Mario Kart. So we're switching over to Mario Kart 64. So you're going to be doing the other controller.
Okay.
All right, it is time for some Mario Kart 64.
Let's see if I can do any better here.
You blow up a lot less in this game, so that's nice.
True.
All right, catching up on some questions. Oh, Ninja Physics redeemed. Take a drink. Cheers, Ninja Physics. Thank you as always for joining us. Dan, thank you for coming by, playing some Battletoads, playing some Mario Kart 64.
Sure thing. Thanks for the invite. All right, we're gonna
Elden Ring. Yeah, that's the new one.
What's that?
The new game that just came out. It's have you heard of like Dark Souls? It's a really hard. It's not a role play game. It's like an open world.
Like a sandbox?
Yeah. It's very similar to that. Elden Ring. They're just really hard games. It's very popular right now. All right. So we've redeemed Take a Drink. All right. Hamsterlicious wants to know, is silicon utilized very often in batteries? At a seminar around 10 years back, I remember one of the researchers talking about how amazing amorphous silicon was at energy storage, but I haven't really heard anything about it since then.
Yes. So the graphite. Wow, they're attacking me. The graphite that I talked about earlier. The trigger doesn't make my mushrooms go.
The trigger underneath?
Yeah.
What?
Yeah, weird, right? Let me try.
So pause. Let's check the controls here. So left, right, up, down, left, right, Z trigger. Push that button. Yeah, it should be good.
Okay.
All right, let's try it again.
Oh, there we go. Cool.
All right. Anyway, silicon for batteries.
Oh, it's A makes the... Oh, so the trigger must be gas. All right, so yes, silicon. So silicon can store more lithium ions than can the graphite we were talking about. And the challenge with it.
Oh man, ruthless.
Yeah, it's the gas is and the trigger are doing the same thing actually.
What are they?
Yeah, weird.
All right, let's try this again. After this race, we'll try to.
Okay.
We can do it.
No, that's cool. I'll finish the race. Yeah. So the challenge is that when you dump all the lithium into the silicon, it changes. It has huge volume changes, and one of the things that is important in a battery is if you're going to move things around, electrons and ions and whatnot, you need good contact between the different components, and when you have huge volume changes.
So that's it. The expansion is reducing contact points, and I didn't know that.
But it can store.
Oh,
how about that? It can't. Yeah. So it has much higher capacity than graphite. Not as high as lithium metal that we talked about early on, but much higher than graphite. And yeah. So it's of a lot of interest, and polymers are an important component of trying to manage that volume expansion and maintain contact, because they can be soft and squishy, and they can,
And Nico has the best comment of the night. No longer mediocre gameplay. Sir, you pulled it out.
Well, it's only 100 cc.
But
keep in mind.
They were skeptical after your Battletoads.
Yeah, I'm sure.
Clearly.
If you joined when I was on the surfboard, that was could have been a 3-year-old doing that.
Hamsterlicious. That's really interesting. I didn't know volume changes were that important. Thank you. I mean, what's underappreciated about any of these devices we make is they need trillions of turnovers. Like, they need to operate so many times and be sustained and stable, and like even a small change over time just adds up. It's like, yeah, anytime you've done like any kind of labor of any kind, like go hammer in a nail 100 times and see how your arm feels tomorrow.
Yeah, right.
Same thing with any mechanical electrical device. It has to repeat so many times, which is kind of crazy. Cuddle Puppy thinks the race is rigged.
Yeah, yeah.
All this is pre-recorded. We just do it to make Dan look good. He's not even playing right now. All right. Two Stangs wants to know, what could you tell us about carbon capture and how polymers play a role?
Well, they don't currently play much of a role. The most promising carbon capture technology is amines, which are a liquid, and basically they can react with carbon dioxide to absorb it, and then if you need to release it, you have to get that to happen, you can heat them, but it takes energy to heat them, and so we're interested in. I'm all over the place.
Yeah, those are some veteran powered slides, though. Clearly played this a bunch.
We're interested in polymers that can do something. Oh wow, that was the last lap. That can do something similar to amines, but where you can do it continuously. So you like pressurize one side, and you have low pressure on the other side, and use pressure rather than temperature. Or you could have maybe a temperature gradient. We have a polymer membrane, and you, instead of having to do it in batch, where you bubble the gas through the amine and then you heat it to remove concentrated CO2. You could have a continuous process, which is going to be preferable if it's possible to make it work.
All right, so we have, man, we're almost at 9:30, and we have 1, 2, 3, 4, 5 predictions left to go. We should probably do another one sometime
Yeah,
soon.
let's do that one.
All right, so you will have to
I like
explain
that
this question.
Okay, sure.
The wording is short,
Okay, yeah,
and I'm not sure I fully understand it. But
yeah.
standard internet units, have them ready because it is time for another prediction. In this case, we are doing another science-related prediction. We'll give them 2 minutes to answer this. All right. So the question is, first polymer to dissolve lithium salts is in Miralax or Teflon coating?
Yeah, so let me give you the background on that.
You have 2 minutes.
Okay.
No
So,
pressure.
yeah, so typically if you want to dissolve a salt, you put it in a liquid like water or an organic solvent. But it was discovered back in the 1970s that you could also that some polymers could dissolve salt, and the first polymer that was discovered that could dissolve salt is also either in Miralax or in Teflon coatings.
All right.
Coating.
I'm not going to ask any follow-ups because we might give away too much meta information. So we will let them spend their next minute and 10 seconds guessing Miralax versus Teflon coating. We are not going to answer any further questions on that till it's over. Note that you are all on Ask a Scientist Gaming Honor Code. You can't look up the answer for any of these questions. You either have to know them or extrapolate from what you know about Dan and his philosophy degree. What answer to this question? First polymers to dissolve lithium salts in, is it in Miralax or Teflon coatings? Sure, either answer is probably an accident, so I look forward to hearing the actual story behind this.
Could have done the shortcut.
Man, we should have done a prediction on whether you'd win this race or not.
That would be a good one.
Yeah, like high pressure. Is the next one the last race?
Yeah.
All right, 15 seconds. Is it in Miralax?
Oh no, I'm gonna come in third.
Oh no, there you go. Oh, Toad squeaked through. All right, Dan, what is the answer? First polymer to dissolve lithium salts in
It's Miralax.
Miralax. So explain this one further.
Sure. So I had a wonderful cat named Jack. He was my pet cat. And he had what we thought was a constipation problem. And so our vet, it turned out to be more serious, but our vet told us to start giving him Miralax every day. And one day I picked up the Miralax and turned it over. And on the back, I saw it actually had the ingredients, and there was only a single ingredient, and it was polyethylene oxide, which was the first polymer discovered that could dissolve lithium salts. And I thought, wow, that's wild. I'm going to open up a seminar with that little piece of information. So the next invited departmental seminar I gave, I opened up with that piece of information, and I enjoyed it, but the audience didn't seem to enjoy it nearly as much as I did.
It didn't land the way you had hoped it would.
So I don't open seminars with that anymore, but it's still,
That's when you have to lead into, treat it like a first date. Don't open with the Miralax factoid. Right. I would have laughed loudly. Thanks, you hamsterlicious. That's why you're here with us, because you have a twisted sense of humor like the rest of us. So we appreciate that. Man, that's crazy. So Miralax, that's the only ingredient. That is what.
Well, and so the story behind. Oh, I forgot the break button. Oh well.
There's a break
I've got
button.
mushrooms. Yeah, B is break, I think.
The Miralax. What is this?
Come
No,
on.
you got the other side.
I got ran over. Oh, you got me, princess.
All right, so we answered the carbon capture and polymers. The answer is not yet, but we're working on it.
Yeah, I was going to say, I don't know the mechanism behind why Miralax is a diuretic, but I do know that if you put it into water at very, very low concentrations, it decreases drag. There's a whole book called Polyethylene Oxide. That's pretty interesting read. And at least if you work with the polymer for your research, like I do. And they have a picture of of experiment with fire hoses, and one is shooting like twice as far as the other. So we do know it reduces drag as well. And so, you know, it's just drag in the intestines.
Is it the book Polyethylene Glycol Chemistry?
No, it's just called polyethylene oxide.
Polyethylene oxide.
Yeah.
Sorry.
They are the same polymer, actually.
Yeah.
All right, final lap. No. Yeah, actually, if you hit a banana and you don't spin out right away, if you hit the brake, it'll prevent you from spinning out. Little fun fact.
It's by Bailey and
Yes,
Collist.
exactly.
Well, that's not bad. I was looking up the price because I was expecting something absurd. The hardcover version is $52. So that's not...
Yeah, and it's in the library.
You can get it on Kindle for $31. So anyone that's interested in a tale of polyethylene oxides, there's a link. Amazon Prime link, because we're on Twitch. All right, catching up on a few questions. Oh, Aniko 2K redeemed request a factoid.
All right. Factoid. Let's see. Yeah. Okay. So we're on this battery theme. I'm going to stick with batteries. So if you overcharge or overheat, or depending on how you go about doing it, puncture, and I'm not recommending you do any of these things. And for the most part, there are engineering controls to prevent it. But if you generally abuse a lithium-ion battery, it can result in a very dangerous fire. The electrolyte in existing lithium-ion batteries is organic solvent-based, and that's because a lithium-ion battery is like 3.7 volts, and if you had an aqueous electrolyte, you'd basically be splitting water. You'd be making hydrogen and oxygen. So batteries, especially these liquid electrolyte-based batteries, there are significant engineering controls in place to prevent any of this from happening. But if you happen to wander onto YouTube and search any of it, you can see some pretty remarkable videos of batteries gone wild. And it's like, and if it's a lithium metal based non-rechargeable AA, like I was talking about earlier, those will actually react with water because they have lithium metal in them, and all those alkali earth, right? Alkali metals, everything in that column reacts violently with water, including lithium metal.
Ninja physics, the appropriate use of the OSHA emote. All right.
Nice.
So you gonna go again?
Yes. Do you think we can get the trigger to do the...
Yeah. So let's try the buttons again. Let's configure. All right. So the directions were fine. Start button, but press the start center. A, B, left bumper.
That's this thing,
Yep.
right?
Right. Z button. Let's try C buttons. That's these guys.
Okay.
So up, left, right, down. And if that doesn't work, I don't know what it is.
Okay. That's cool. I mean, I can use them. I just does it. All right. So I didn't come in first, so I guess I shouldn't go to higher CCs.
All right. So should we do a will Dan win this race?
Yes.
All right. We're going to do a 30-second prediction. Will
Who-
Dan win the next race?
Let somebody choose who I race with.
Oh, whoa. We're being bold here. Does anyone have opinions who Dan should select to race? It's about a 15-second delay, so
Okay.
we'll give it a second. Somebody's got a strong opinion. Donkey Kong is the
Alright.
first response. So, Donkey Kong, no explanation needed. We're going with Donkey Kong.
All right.
Before you start racing,
Yes.
which cup are you going to go with?
Good question.
Which race?
Let's go with... We're going to go with Toad's Turnpike. Flower Cup.
Flower Cup, Toad's Turnpike. All right, you guys have 30 seconds. Is Dan going to win this first race? Will Dan win the next race, yes or no? So they have 30 seconds to answer, and then...
Should I start playing, or...
No, wait.
Okay.
They need no preview. They're just going to decide.
All right, cool.
We're actually betting on video games this time. All right. In the meantime, Faithful Fairy wants to know, I wonder how uniform polymers look under a TEM. Their structure got to be related to their function too. My grad school buddy did a nanoparticle research, but I never liked their TEM much, and I almost fell asleep during his defense. Additional details, not necessary, but thank you.
That's great.
Anyway, have you done a TEM of a polymer? Do you know what they look like?
Yeah, so it depends on the polymer.
So for those of you not familiar, TEM is a transmission electron microscope. It's basically a higher resolution microscope than you can get with optical. So you can see really, really small things. Anyway.
Correct. The problem, I guess it's problem in the context of TEM with polymers, is that they are sensitive to degradation, much more sensitive than inorganic materials like the nanoparticles that your friend was probably studying. So you have to be somewhat...
All right, we're ready.
You need to be somewhat careful about how you image them in TEM. You need to reduce the power of the electrons you're shooting at the sample.
Before you start, do you want to know what people think? Do they have faith? Are they believers? Or are they skeptics?
I can see. I looked over. I'm going to prove all you naysayers wrong.
Well, here's the thing. 4 people said yes. 1 person said no. But the person that said no bet twice as much as this that said yes. So they're confident you are not going to do it.
Okay.
So it's a mixed bag this time. But anyway, sorry for interrupting.
No, that's okay. This level's easy. Yeah, so they're hard to look at, first of all. Oh, the trigger's working now. Sweet.
All right, fixed it.
Yeah,
Nice.
you sure did. I'm gonna hit the truck. Hit both trucks. Nondescript, if it's just a regular single chemical structure polymer. If it's something more sophisticated like we work with, like block copolymers, then you can see pretty amazing structures, actually. Still on the first lap. There's a lot of game left.
No worries.
So yeah, not as interesting and not as beautiful as nanoparticles typically, but if you have a well-ordered block copolymer, they form some pretty beautiful structures. My power turning is not working very well.
No worries. All right, Faithful Fairy, talking about batteries, did the graphene craze make it into battery field too?
Well, I mean, not really. Graphite is already used in batteries, and that's, you need to exfoliate graphite to get graphene, and so no, not so much. I
mean, my understanding of graphene, it's got a lot of amazing properties, but it's kind of hard to produce on an industrial scale and like process it and control it. So,
yeah, I've heard that as well. All right, last lap.
All right, 3rd place, no pressure. 5 people are on the edge of their seat wanting to know the outcome of this race.
2nd place, but I don't see the 1st place racer. We better get some power turns going.
A mushroom or 2.
Come on, DK.
I'm on the edge of my seat too.
Oh, I got one more. Question mark.
Ooh, nice slide.
Oh, what?
What? That was brutal. Not like this.
No.
Not like
I'm
this.
sorry for letting you down. Oh, is that not the finish line there? This course is longer than I realized.
There's still time. And a star. Little rubber banding effect.
I got her.
Oh.
All right, sorry everyone.
The answer is no.
Well bet.
The skeptic takes the win. They bet
win.
big on no. And they were right.
I'm impressed.
Nobody makes it past those. Who's the skeptic? A big spooky skeleton. Congratulations on your standard internet units. A 1.67 to 1 payout to betting big on the no answer.
I did.
So
it's Is it just one, or we need to drink 4 when they're
No.
4?
That's not a request to drink. That's just one of our emotes because we're
alright,
alcoholics on this stream. Turns out Twitch is okay with you drinking as long as you're not too drunk. Then it gets red flagged as
Really?
an area of concern. Yeah. It's written in their terms of service actually.
Huh.
All right. Okay, catching up on something hamsterlicious, very fundamental polymer question. Okay, so I think I might have a misconception when something counts as a polymer. Is it a particular type of periodicity in the simple chains?
It is basically a molecular weight or molar mass. So there is not one. I don't remember this many. Remember that many snowmen in this level.
Yeah, that was pretty brutal.
Not playing well. There is not one like super concrete definition of a polymer, but the most general is high molar mass molecule, which most frequently you get by linking together a bunch of the same small molecule repeat unit, which we call a monomer. I got lucky there.
So the repeat unit is intrinsic to the definition. Repeat?
No. Like DNA is a polymer. And it can have any number of
I see.
of order. But yes, there are building blocks that make up a polymer, I suppose. And whoops. It doesn't have to. Yeah, it could be. I guess in theory you could have many different monomers, and if there were enough of them, and if it was high enough molecular weight, it would probably be considered a polymer. Okay, so who knows where the shortcuts are?
The gold mushroom, the answer is everywhere. That's
it seems like there's a limit to how far.
So I'm a molecular person, but what's kind of fun is you start out with a monomer, right? And then you can get a dimer, a trimer, a tetramer, a pentamer, and eventually you use the word oligomer.
Right.
And then eventually you start using the word polymer, and there's no clear delineation.
There's no clear delineation.
Yeah.
Maybe 100 repeat units is sort of where you might say it goes from oligomer to polymer. Oh, really? That was last lap? Should have tried harder.
You should always be trying.
I know.
Scientist gaming.
You're asking me to play video games and try to think.
It's true.
Multitasking is bad for your brain.
That's true.
Factoid. Free factoid for you.
Drinking while multitasking is worse, so.
Well, maybe not, though.
That's true. I need a psychologist on. Actually, I think in a month we have a developmental psychologist on. I'll ask her.
Awesome.
All right. First time chat from Marzipan Polly. Welcome to the stream. What type of polymers do you use and why?
I'm really interested in nanostructured materials. So these are basically materials that have more than one type of monomer. Or I'm going to speak continue to talk in the context of polymers, although we do some work with nanoparticles too. So when you have more than one type of monomer, and if you put a bunch of one type of monomer in a row, get up on the ledge there. And then a bunch of the other type, you have what you call a block copolymer. You can get what you have a block copolymer, and they form these cool nanostructures. And what I mean by nanostructure is basically that it has structure. It has some it's not just a simple pattern, but it's very small. Nano, as in nanometer scale, length scale. So what? The diameter of an average human hair is 100 micrometers, right? So we're talking what, 1,000 times smaller than that. And the reason we're interested in nanostructured materials is,
Ooh, that was cozy.
yeah, that might have been a little bit of luck there.
It's fine.
Is because we want to have mechanically strong material that can resist lithium dendrites, for example. Will we squash each other?
I don't think so. I think if you're both small, you're okay.
But we also need to conduct ions. And those are two like diametrically opposed things. To have something that's mechanically strong and but then it has a lot of mobility to move ions is oh, he got me. I'll be darned. Oh, and I got myself. Wow, I didn't know you could do that. Don't let go of your question mark while squashed.
Fun factoid.
So what's cool about nanostructure is that it can allow you to have both properties in one material, because you have these small domains, these small microphases that the ions move through, and other small regions that give you your mechanical strength. So we do a lot of work with. Oh, I can retry. Oh, because I dropped so far down.
Yeah, I think if you get less than fourth.
Oh, I didn't realize that. So we study black copolymers a lot. I mean, and I can go into like the I'm going to ask you back a question. Do you want me to talk about like the type of chemistry of the polymers we study, or is
Marzipan, if you have any follow-up, throw them in chat. If you want to go into detail, Dan is happy to do so.
Yeah, definitely.
Or we can move on. It's totally up to you guys. We should probably do another prediction because it's already 9:46.
Okay.
Which one do you want to do?
You want to choose it for me?
Not
Here.
really.
Okay. All right. Yeah, let's do. Okay, we did a technical one last time, right?
Yep.
Okay, so let's do a personal one. Yeah, let's do that first one up at the top.
All right. So tonight we learned that Dan was a double major in chemical engineering and philosophy, and we learned that through a prediction question. We're going to throw another, what do you know about Dan, and how does it translate to predictions on Twitch? So you have 2 minutes, use your standard internet units, gamble them on this question right here. It is, what's Daniel's favorite sport as an adult? Is it surfing or rock climbing? It's presumably different than your favorite sport as a child.
Yeah.
You added that detail. But right now, what is Dan's favorite sport? Is it rock climbing or surfing? Based on what you know from his Mario Kart gameplay, as well as expertise in polymers and his undergrad degree in philosophy and chemical engineering, what does he like more, surfing or rock climbing? There's just no way they would know this answer. Right?
No.
Short of your students and you talking about it in class.
No, just which we haven't.
It's not something that casually comes up often. Surfing or rock climbing? We got 50-50 split in terms of the money bet on this one. All right, do your predictions now. If you're not following, click the follow button right now. Get your 300 standard internet units and bet them on this question that you can't possibly know the answer to. Or maybe you do. I don't know. Maybe Dan has tells associated with how he behaves. I'm going to bug you in group meeting about this. Oh no, you revealed too much. Be used against you. So, Two Stranges is a student of yours, presumably, but will still remain anonymous.
Yeah, I can guess. One of my students said that, I'll say they, so as not to give anything away.
That's fair.
We're definitely going to come. Oh no!
Oh, that's going to cost him.
Game.
Oh, that's brutal. I'm sure there's a way to jump up there if you're speed running, but man. Wow. Oh, Marzipan followed up. Just the type that you use specifically for your research.
Okay, yeah, so... yeah, did you see that? I've recovered from a banana. So polyethylene oxide I mentioned before, that is the polymer. I'm going to try it one more time.
That's your go-to?
And is the one block of that block copolymer I was talking about. And polystyrene is the most common other block that we study when we are studying these block copolymers. The polystyrene has what's called I'm going to try one more time, a glass transition temperature of about 100 degrees C, and it depends on a number of factors, but up around there. And so at room temperature, it's glassy, and it when you combine it with rubbery polyethylene oxide, you get mechanical strength. And you have the polystyrene phase that sort of keeps it strong, and the polyethylene oxide can move the ions through it. And so it's pretty interesting in that regard. Polyethylene oxide is such a remarkable polymer because, in addition to dissolving lithium salts, it has favorable interactions with carbon dioxide and with water. It's hydrophilic, and so that's why it's a pretty integral component of the materials we study, and that's why we're interested in these different sustainable energy applications. But that's not why, but it's because you can make a big difference in the sustainability of technology if you can improve these three sort of water, energy, food nexus is a really important challenge that's recognized by like National Academy and funding agencies of national American funding agencies and also sorry, I kind of lost my train of thought there. Completely lost my train of thought.
No worries.
It's like a brain fart, right?
Yeah. No, it's on the ledge there. I understand. So we're talking about polymers you use and why you use them.
Yeah. So but still, I kind of
No,
not sure where I was going with that. It's polyethylene oxide polystyrene is the one we most we do the most work with.
All right, so prediction. Daniel's favorite sport as an adult. So 2 people said surfing, 5 people said rock climbing. Those that said rock climbing bet 421, said surfing bet 300. And the answer is?
The answer is surfing.
Surfing. So 2 people were very confident you were a surfer. Where do you go surfing? Is there any?
I mean, there's sometimes waves on the Gulf Coast.
Mm-hmm. So you like follow the Nice. Earned it. That was beautiful.
No, you can't really. So the Gulf is pretty sheltered, and so you basically need a thunderstorm to come through, and then you have waves like the next day.
I see it.
Or shortly after the thunderstorm happens. So no, there's no real predicting that. I have a brother-in-law who lives in New Smyrna Beach, and they have like waves pretty much all the time of some sort, some rideable sort. So those are the 2 most common places I'll go these days. I learned in North Carolina between undergrad and grad school, and I'm actually really glad I took some time off. Not so much to learn to surf, although that was a blast. Learned to cook because I made for those years I made a living working in a restaurant cooking. More so just because I was not a mature undergraduate student, and I would not have gotten out of graduate school what I got out of it if I had gone straight from undergrad.
Yeah.
So, and that's not to say like I don't want to discourage anyone from going straight to grad school, because nowadays when I see right at it, don't look at what you don't want to hit.
Good advice.
Our undergraduate students amaze me, how driven they are, and so if you're ready to go. It's so much easier. But
for you, it worked out.
It worked out great.
So Steele's Lunch apparently said you said during Battletoads that you served.
Oh, yeah, I did, didn't I? That's right.
So kudos for paying attention and staying the entire stream, because. Was that during the
when he was on the
level?
and during that painful 15 minutes of.
We know who wasn't here. Oh, so people actually knew the answer. At least a couple people.
That's awesome.
Steele's Lunch did at the very least.
I did not do that. I did not give that away on purpose.
Yeah, you gave away the meta information. You ruined the question.
Yeah, but it still worked out.
Yeah, I know it did. Congratulations on your 2.4 to 1 payout, whoever said surfing. That's pretty fun. All right. Steele's Lunch also has a question. Do you know of any polymer that can have their permeability reliably changed through external stimulus?
Ooh, yeah, cool question. So you can. I'm not sure of like a commercial off-the-shelf answer to that. I'm not sure if there is. There might be, but you can imagine making a block copolymer where one. Oh, that was last lap. Huh? Where one block is like polystyrene, and instead of polyethylene oxide, you make it like a responsive polymer. Like I'm going to get myself in trouble by only being able to conjure the acronym, but so PAMPS is a polymer. It's a really cool one that's used a lot in like drug delivery because it goes through a reversible transition at 37 degrees, or between room temperature and 37 degrees Celsius body temperature, so it'll have very large swelling and deswelling volume changes if it's in the presence of water. Like it'll basically take in water and let water out, depending on whether you're at high temperature or low temperature. So you could imagine like making a block copolymer where then you had a response, and you could, there are a number of ways to go about this. You make a block copolymer, like maybe a tri-block, and
What?
he had a star though too. Yeah.
I didn't know you both smushed like that. That was weird.
So you have like, let's say polystyrene, you've got like this PAMPS I was talking about, and then you've got polylactic acid, and it orders into some structure, and once you've made that structure, then you etch out the degradable polylactic acid, and you're left with pores, but those pores are lined with this responsive polymer. And so if it's at, I don't remember which, whether it's hot or cold that it swells, but you can imagine swelling and deswelling those pores, which would increase and decrease the permeability reversibly. So yeah, definitely is possible. Another really interesting class of polymers with permeability that are of interest, like for gas separations, are these polymers that have like really big, bulky functional groups. There's a whole class of them. They're called PIMs, polymers of intrinsic microporosity, and the groups are so bulky that they have like really large, really high free volume, and so they have high.
Oh no!
Man.
Oh. I mean, you're in 7th. Not that bad, but oh, nice. Yeah.
Dang. I'm going to try one more time.
So Steele's Lunch redeemed, take a drink. So cheers, Steele's Lunch.
Cheers.
Thank you. Hopefully you have a drink in hand, drinking with us on a Wednesday night. Unless you're students, then you should be studying while listening.
That's right.
About dance surfing. Will this be on the exam? Steele's Lunch paid attention. So if it was, they were ready. All right. It's almost 10 o'clock. Anyone just joining us? The guest today is Dr. Dan Hallinan, who's an expert in polymer engineering, particularly for polymers for sustainability, things like more efficient or smaller volume batteries, or CO2 sequestering, or desalinization. We haven't talked about that.
No.
Somebody asked a question about desalinization. I don't know what that question would be, but it's an intriguing area. It's I mean, you're talking about reverse osmosis and membranes for that application, right?
Mm-hmm. Yeah, absolutely. Yep, exactly. I'm going to wait for somebody to ask a question.
I mean, I could ask a question, but it feels like cheating, right? I mean, but yeah, rather than wait. So I did not know a star would destroy trees like that.
Really?
That is awesome. Yeah, I played the Super Nintendo version of this.
Oh, okay.
Not the Nintendo 64 one, but I don't think I've ever seen that.
Yeah, so, I mean, you basically, you want to move water and not ions in desalination membranes. So you need what we call selectivity. So you want to move water, not ions, and you man, I really can't talk and play well at the same time.
Yeah, you're in first. You're under pressure right now. I get it. Nice.
Woo!
Earned it.
661. I did that the past 2 tracks. It's like I just need to warm up or something. Yeah, so you want to move water, not ions. It's called reverse osmosis because naturally, thermodynamic driving force, if you put salt water on one side of a membrane, a semi-permeable membrane, fresh water on the other side of semi-permeable membrane, you can ask if any of my polymer physical science and engineering students are here, they know what the driving force difference between those two sides is. But I'm going to go ahead and say it. It's osmotic pressure. And so that's going to drive fresh water into the salt water to dilute the salt, and because the two phases, the lowest energy state is for both phases to have the same concentration. But if the salt can't move through the membrane, and only the water can move, you've got water coming from fresh water to salt water. And so you have to actually apply pressure to the salty side to drive the water through and get fresh water out. Whole lab watch party going.
They got you up on the projector playing Mario Kart.
And so the reason that we're interested in desalination with reverse osmosis is that it's much more energy efficient than distillation, than basically boiling the water off and condensing the water. The salt doesn't evaporate. So that is actually, there's not really much effort in that direction in my group currently. There are some reverse osmosis desalination plants. There's one in Tampa apparently, and in the Middle East and in California. Again, it's moving things, or selectively, those things being in this case water and ions, through a polymer membrane.
So we're at 10 o'clock. Do you want to change games? Do you want to go one more?
Yeah, I'm gonna do one more. I'm gonna try to get first place in a 100cc, and I'm gonna go with Mario, and I'm gonna do Star Cup. So, yeah.
When I teach Gen Chem 2, I talk about osmotic pressure, right? And there are people that are proposing to use osmotic pressure to run hydroelectric plants. I don't know if you've ever seen this. But essentially, anyone that's not familiar with osmotic pressure, if you put salt water next to like pure water, and you put a membrane in between that only transmits water molecules, the pure water will move over to the salt water. And so what that means is the volume on the salt water side gets higher, which means if you have it go high enough, it could run downhill as like a waterfall and run an actual turbine. So theoretically, through this passive osmotic pressure process, you could actually generate electricity, which is a crazy scheme, but the math works out. It should work. I think the fundamental limitation is you need a membrane that works with, like, the only place this would work is where you have like a freshwater river draining into a salt lake or ocean or something, and then you essentially set up a factory on that edge where you have a semi-permeable membrane between them, and you use it to drive hydroelectrics.
Yeah.
And I guess the only issue is that the membranes, I mean, it's got to deal with a lot of crap, like everything from algae to pollution to whatever microplastics are in there. And so this does work, like the math checks out, but it's not cost effective, because if you have to replace or clean your membrane every, 100,000 kilowatts you generate, it's not cost effective. But
yeah, there's some other interesting ways to go, like electrochemical on it, where you pass like your high salt through something that can intercalate ions, and then you pass your low salt through to deintercalate, and you can actually get whoops, whoa. You can generate electricity through that cycle.
Mm-hmm.
Oh, wrong way.
Scuzzbot has redeemed Take a Drink. We'll wait till after your race for that.
Okay.
They're just messing with you.
Second lap.
All right, Ninja Physics. I'm interested in energy storage for buildings. Any applications you work with?
No, not that I work with. So there's some really interesting energy research on buildings. Wow. So buildings can be their own storage of energy. Like if they're big enough, where you basically, if it's got enough thermal mass, so you sort of like heat it when energy is abundant, being generated by whatever sun or wind or whatnot, and then turn off the HVAC or turn it down during times when there's high demand but there's not high generation. So they can be a sort of like energy storage. Man, that's gonna cost me missing that.
Nice power
But missed another one. But so for stationary power, oh no. Flow batteries are got me.
Oh, ouch.
And I'm gonna take myself.
Ouch.
Are really interesting. We're not working on it, but third place. Oh no, one more
We
lap.
got one more lap.
Woo!
I mean, so how different are batteries you use in your house versus in a car?
Well, if you're using them in your laptop or in your cell phone, they're the same.
Mm-hmm.
I mean, or very similar. Maybe like a slightly different chemistry, but they're going to be lithium ion. But for large stationary power, flow batteries are super cool because basically there's a trade-off in batteries between power and energy. So you can store more energy per some like battery design by making thick electrodes. But you can't discharge it as fast as you might want to if the electrodes are really thick. And so on the other hand, give me something.
Oh, no pressure on this snipe. You are focused. Laser focused. This is a vendetta at this point.
Oh, as I crossed the line.
Oh, wow.
Oh my gosh, I can't believe that.
I'm going to replay that.
So that drink, here's that drink.
Yeah, cheers, Scuzzbot.
Cheers.
Thank you for the redeeming take a drink, because you need one after that. That was harsh. That was
I can't
brutal.
believe that. That is Mario Kart at its finest. If you're in first, it does everything it can to make you fall back, and if you're in last,
So that phenomena, it's called rubber banding. I don't know if you ever heard that terminology.
I heard you say it earlier, and I thought, oh, that's a nice term.
Yeah, no, it's an apt description of what they do to you when you're in first place. And sometimes it's better to stay in like third until the last portion. And,
Right.
Yeah.
Well, it's enough to continue on anyway. So I know I was in the middle of describing something when I got focused.
Well, we're talking about difference between like a cell phone, computer, house versus car.
Oh, right. So flow batteries are cool because if you take the active material that is the electrodes that does the reacting, and you have it be a liquid that you can pump, then all of a sudden those power energy limitations get decoupled because you just need a bigger tank with more of your active material to have more energy, and you can flow it through there and get the power. Design it for whatever power you need, and then
Nice.
and then
Veteran.
assemble your. Yeah, but can I do it on lap 3?
A good question.
So flow batteries, very interesting for stationary power. But you wouldn't. I don't think you would have one of those like in your house. That's more of like an industrial storage sort of thing, at least my understanding of it at this point.
Speaking of power, we should probably do this one. AAA battery versus, or AA battery versus
that's a
E-Car.
nice one.
All right, we got a related prediction, ladies and gentlemen. Get ready with your standard internet units. We have another prediction. Dan is going to explain this one after he's done with the race. Less than 500. Do you want to wait till after the race for me to pull the trigger on it? You're ready to go?
Yeah, it's okay. So you want me to just like...
Yeah. So I'll put context on it, or I'll say the question, and then Dan will provide context. A AA battery equals E-Car drive 10 miles or 16 kilometers. Is it greater than 500 AA batteries or less than 500? So yeah, go ahead and put.
Yeah. So basically, I'm saying like if you were to take sort of the average amount of energy needed to drive a mile in an electric vehicle, I used Tesla specs. How many the amount of energy it would take to drive 10 miles? How many AA batteries would it take to get that amount of energy?
Yeah.
And is it more or less than 500?
So I guess framed a different way, how many batteries would you have to put in an electric car to go 10 miles?
Right.
How many AA batteries would it take? Is it less than 500 or greater than 500? That's fun. That's a lot of batteries.
Yeah,
like when
right.
you talk about volume and energy density, that's a fun calculation. So AA batteries equal to E-Car driving 10 miles. Is it less than 500 or greater than 500? Throw your answers in there now. You have about a minute. Sometimes I hate that I know the answers to these, because when you send them, the answers are there, because I want to know what my blank slate would think about these questions, because that's... That's a fun question. We'll talk about...
Oh no, in the drink.
In the drink. That's a lot of batteries. Maybe. The answer could be 2. It's less than 500. But it's probably not. All right, 15, 20 seconds. I feel like I could guess better if I drove an electric vehicle.
Yeah, you should.
Yeah.
Well, they are still pretty expensive.
So we looked into it. We committed to a minivan with our last purchase. There aren't a lot of electric minivans out there.
Yeah. So I had to pre-order, but I have a Ford Escape. Mm-hmm. They don't make the Focus anymore in plug-in hybrid, but they make the Escape, which is sort of like a car chassis SUV sort of. Wow. Can't adjust once you're up there. Which will be, I wanted to get like all electric, but my wife's Subaru is kind of getting old, and so we wanted a backup. Mm-hmm. Where does this take me? I thought there was a shortcut.
I do not know this map at all.
Reverse? No, I can't go in here.
I'm working on it. I was interested in the Atlas XT. It's apparently a new electric vehicle that's coming out.
That one actually didn't come across my research. I did check out the Aptera, which is still, it's like a startup company and you can't even get them yet, but it's got solar panels on it, so its range is huge. Oh my gosh. Can I just restart?
Yeah, you are getting absolutely destroyed right now. Oodles of Omics, thank you for the tier 1 sub. That's 12 months. They have been subbed for a year. Thank you for joining us. It's been a year. I think you're officially our 30th guest.
Oh, really?
On the stream. Yep. So yeah, we've been going at it for almost 2 years now. Not necessarily every 2 weeks. That's a fairly recent development. But Oodles of Omics, thank you for joining us. Again, if you have questions, we're happy to answer them. If not, just sit back and watch Dan get wrecked in Mario Kart. Like, the last rounds were good, but this one
Is
been brutal.
Yes. Well, I guess I tried to find a shortcut.
Yeah.
Was really the root of it.
They don't let you restart. That sucks.
Well, they'll let me retry though.
All right. So in the meantime, how many AA batteries do you need to drive the equivalent of 10 miles in an electric car? What is the answer, Dan?
Greater than 500. It's like
Greater.
693 or something.
So you'd have to pack your car with 693 batteries to go 10 miles in an electric car. That is a lot of, I mean, even cubic closest pack, that is a lot of space for batteries.
Yeah, definitely.
So that was based on, you did that math on the Tesla.
That was based on, Tesla specs for kilowatt hours per mile. And I just used like 3.9 watt hours as a typical capacity for a AA battery.
You should have your students do the volume calculation on that. Like, how large would that AA battery stack be versus the battery that's in an electric car right now?
Yeah.
Oh, God, Rainbow Road.
Yeah, this one's fun. I think if you fall off in the right spot, you can drop down onto the...
Yeah, I've seen that in the speed runs. They intentionally just drop into the next. All right, so if anyone has questions, throw them in chat. If not, I'm going to ask a few of them. So you had some time to think about this one. What movie or TV show gets your discipline wrong and what gets it right?
Yeah. So, if I'm talking about my discipline as in polymers specifically, the movie that definitely got it right is The Graduate, with that famous quote where Mrs. Robinson's, I think, husband goes up to the main character, who's it, and says, "Plastics, the future's in plastics." And it's just like in 1971 or something, and it was true. The future was in plastics.
If you did your economic investing based on The Graduate, you were in a good place.
Yeah,
that's awesome. That is the most unexpected answer I've gotten so far for this question. I mean, because it's not like applying the science, but more of a speculation based on where the science is going to go, which is awesome. Like, that's what most sci-fi writers do, but not as literally, right?
Right.
So that's really fun.
So there's actually a really cool book called so if my group is the one who's having a lab watch, I need Ashley to give me the title of the book that I lent her. It's what's it called? Something Wizards and Aliens. But it's all about, like, it takes a bunch of common events in sci-fi movies and analyzes them from, like, mainly it's from a physics perspective. I think it's a physicist who wrote the book, but it's pretty interesting. Something Wizards and Aliens.
Is it Wizards, Alien, and Starships, Physics and Math and Fantasy?
Yeah, that sounds right. Yeah.
All right. That's fun.
But I didn't tell you which one got it wrong. And so now for that one, I'm just going to go more generally, like, engineering. So as a kid, I was a huge fan of the original MacGyver show. Paperclip, rubber band, and that's about it. And he thwarts the bad guys.
Just literally anything.
But the new MacGyver, it's not a bad show. It's entertaining, but just some of the stuff they do, and more so now that I'm in research and know the speed with which they do it. They solve a major science problem that 100 different groups have been working on for 10 years. They solve it in 5 minutes somehow, magically, in order to keep the plot of the show moving where they want it to be moving. So That one I feel like sort of gets it wrong. It gets engineering wrong because it's like
Just gets the
unrealistic.
process wrong in its entirety. Yeah, like foundationally. No, those are really fun answers. So you'd recommend the book Wizards, Aliens, and Starships?
I really enjoyed it. Yeah, I mean, if you like science fiction and you like science and you want to see science fiction, like sort of critically evaluated, and it basically sort of goes through and is like in a objective way says, well, what is based on what we know today about from hard science, like what is realistic and plausible, and what is just like violating fundamental laws of science.
Who breaks the science? No, that's fun. So that book came out in 2014. I added it to my box of books. So I listen to audiobooks while I bike into school. So
oh, cool.
That is a perfect addition.
Wow, you bike this? Well, yeah, you're on main campus. That's awesome.
Yeah. Well, it's about 20 minutes from here to campus, so it's not too bad.
On bike?
Yeah.
Nice.
So it forces a workout, but also I get to work out, so that's kind of nice.
Yeah, and it's even more sustainable than an electric vehicle.
Yeah, no, that's true. Well, we'll see. I'm getting old. It has a lifetime, that's for sure. The hills are not forgiving up Meridian.
Man, people in Italy live to over 100 regularly, and
that is very
you see
true.
people in like suits biking to work there.
Respect. All right, Oodles of Omics wants to know, sorry I'm late. So I'm working with people who are sending mass spectrometers into space right now. Since they require a lot of power, I was wondering what would be the best battery for space and how would you protect it?
So the batteries they put in satellites, or at least did, are they're called metal hydrogen, I believe.
Huh.
And so they're insanely expensive, but they don't have really any appreciable fade. So you can essentially charge and discharge them like 10,000 times and still have the same sort of performance that you had when you first made the thing. And so if cost is not an option, or longevity and storage is really important, then I think it's called metal hydrogen. So that was from like a battery course I took as a postdoc. So that's like over 10 years old, that information. So I don't know what they're using like on the space station, for example.
So that's solar cells coupled to those batteries. Is that how they do it?
On the satellites? Yeah, I believe so. Right. Yeah.
The other power source they regularly use in space is they'll couple nuclear decay that generates a lot of heat to a thermoelectric that converts heat into electricity, which I think is the other way. But I don't know. Yeah, I don't know state of the art what they use. I'm sure it depends on what the application is and what they're targeting. All right, 1022.
Yeah, let's do another game. Yeah.
All right, which one do you want? Ice hockey?
Yeah, that sounds great.
All right. We're going to switch over to ice hockey, ladies and gentlemen. So we're jumping back in time. We're going to 1988, the original Nintendo Entertainment System. I will fight to the death anyone that argues with me on this. This is the best hockey game for the Nintendo Entertainment System. we played with Blades of Steel earlier, but this is arguably better than that. So you have to pick your opponent. All right. And you get to pick your size of your hockey players.
All right.
They can be big, medium, or small.
All right. Big is good at defense and hitting. Small is fast. And we'll go end. All right.
Two Stings wants to know, why is there no chemistry in chemical engineering?
There is. There's just not much in the... There's just not much in the research I do. Because if you were listening earlier, I'm not very good at chemistry.
That's why you collaborate.
Yeah, exactly. Yeah, that's why I collaborate with quite a few chemistry professors, because I like the physics side of chemical engineering. We actually do a ton of
Wow. I'm tearing it up here.
Physics-based work. Yeah, don't jinx me.
We should have had people gamble on this.
Woo! Is there like a speed record for ice hockey?
Probably, but the speed records in sports games is basically you kill as much time as possible without doing anything and then win at the last minute.
Oh, nice defense.
Oh, there's a link for the Atlas XT electric pickup truck.
Oh, nice.
Looks.
Oh, okay. Actually, I'm sorry. I said that hadn't come across in my research. I was wrong. That I did see that.
It's a pickup. Looks much better than the Tesla pickup.
I'm not. Ooh, that we almost got in a fight. I forgot you can fight. I'm not much of a truck person. I know that's like sacrilege to say here, but
here on Ask a Scientist Gaming.
no, I mean like in Tallahassee, Florida.
That's fun. I'm going to just show you guys briefly.
I don't really.
Oh wait, browser's
I don't
not showing
have
up.
a need for a truck in my life. Oh, he scored on me. I did pay extra to get racks on the vehicle I ordered though, because it's nice to be able to put a surfboard up there. But
that is a pretty looking vehicle.
yeah,
Figure out if I can share this link.
you're talking about the.
Well, I can switch to a different view if I get it up here. My different browser. All right. So there it is. That's the Atlas XL electric pickup truck. It's fun. I love that they reduced the car down to this. I don't know if you see this image,
Yeah,
but that's it, right? That's the drive and the batteries associated with it.
Wow.
How many AAA batteries could you store in there? That was 600 batteries to go 10 miles. The capacity of these is what? 300 miles, something like that?
Yeah, 2 to 300. It's typical.
200 to 300 miles. That's pretty fun. So what would we need? 20 times... We have a request to quiet down a little.
Down.
Yeah. The kid is sleeping in the next room. Yeah. All right, so you need 12,000 batteries, 12,000 AA batteries to match the capacity. Sorry, I'll get back to the games.
Yeah, and but they don't have. So we're talking. So AA are not, don't have nearly as much capacity as a lithium ion, and so the number of lithium ion batteries, they call them 18650s, which has to do with basically the size of the cell. It's like a AA on steroids.
Mm-hmm.
They store a lot more, and so they have somewhere around 2,000 or so lithium ion cells in a typical. All right, here we go. It's time to score.
It's time. Ladies and gentlemen, it is time to score.
Where's my defense?
So anyone that hasn't played this game, you control the goalie and the players, which can be a conflict of interest sometimes. Because you try to chase them down and then your goalie's in the wrong spot.
Right.
I mean, what do you do?
Yeah, focus on your goalie if they're shooting at you.
Oodles of Omics, thank you for the tier 1 sub gift. Dr. Pinner, congratulations on the surprise gift sub. Oodles of Omics, we appreciate your support. It's always a pleasure to have you here. If you have questions, throw them in chat. Same thing with you, Dr. Pinner. Enjoy your emotes. Emotes including Deity Carl Sagan as well as Mr. Big, which we'll get to a little bit later. But again, thank you for the support. We really appreciate it. It helps our drinking, gaming, and science habits. So you don't have to support us, but we appreciate when you do. So thank you very much for that. All right, we're going to catch up on some questions here.
Yeah.
Which of the two would help mitigate climate change more readily? Carbon capture technology for use at scale or zero carbon technologies for energy use in buildings and transportation?
Well, I mean, knowing mass and energy balances is a huge part of chemical engineering. And so, based on based on that, you got to stop like producing it. And so now I haven't done any calculations on this, and this might not be. We almost got in a fight.
Oh, you haven't fought yet?
No.
I love the fights in this game. You have to get it in at least one. Nice.
Tied it up.
Tied it up. Well done.
So I'm much more a proponent of developing zero carbon technology than capturing it. I mean, I think in reality we need to do everything.
Yeah, that's one of the things I hate most, because I'm a solar cell guy, right? So I go to conferences and everyone's talking solar cells. But when people go up there and say solar cells are the answer, I'm like, you're full of shit. The answer is everything. It has to be all of it simultaneously. It has to be, reuse, recycle, plus, prevent CO2 production, plus solar cells, plus all of it. Better
Come on,
batteries.
pass it. Why won't he pass it?
Man, you were tearing it up earlier.
I know.
With like
I
3
think
gold.
they got better.
Rubber banding in Nintendo. So you're a proponent of mitigating for these types of things. I mean, the capture of CO2 is non-trivial.
Oh, I lost.
Because for the most part,
Yeah.
you need a high concentration of CO2, and it's not. I mean, our atmosphere has CO2, but not necessarily enough to readily react with it in terms of a chemical reaction.
Yeah,
So,
exactly.
I mean, you got a couple problems to deal with there. All right, Oodles of Omics wants to know, any thoughts on biobatteries, advantages, disadvantages, advancements?
Yeah, so I mean, there's sort of this big research push recently on. I have one more. That's right, it's 3. It's hockey. Yeah, I've seen some interesting. I saw an interesting review article on biobatteries that are biodegradable. And so you basically can like put them into the. Oh yeah.
Are you trying to get in a fight now?
Not really, but
If it happens, it happens. Anyway, review article on biobatteries.
oh yeah. So so basically, I passed instead of shot. Come on, guys, pick the puck up. Yeah, so the idea is you can implant them into the human body because they're completely non-toxic, and they give you energy for a while, and then they degrade into getting whooped. They degrade into non-toxic components that can then be naturally removed by processes of the. Get it.
So imagine, I haven't looked into biobatteries, but like comparing natural photosynthesis versus, say, solar. Wow, that
What
was
a shot.
Very nice.
I'm
But
not-
comparing like natural photosynthesis versus solar cells, like a lot of the energy that's generated from natural photosynthesis is mostly going to repair and maintain the structures. Like that's inherent to biology, that you have to replace the photosynthetic center every like 45 seconds or something. I mean, in biobatteries, I imagine there's a similar issue. Is this actual like algae that you're trying to harness, or what are we talking about in terms of biobatteries?
well, these are
Nice.
These that I was looking at, they're still, I guess they were biocompatible and biodegradable.
I see.
But they were not
Actual living.
like, although there are like microbe-based fuel cells. Shoot! He was doing some Gretzky maneuvers there.
Yeah.
Need
Don't
to
call it-
remind me
200.
not get too.
No, it's okay. As long as we're not constantly yelling, we're okay. E. coli has shown some promise. Yeah. I've seen that, but again, like it's a cost benefit of how much energy goes towards to maintaining the biological portion to how much do you get in return. Oh.
Right. Yeah, and they're such low power. I mean, like they're orders of magnitude different than.
I guess it depends what application you want them
Right.
for, right? You're not going to get a high energy density release. But I mean, that comes with all these, right? It's a balance of...
Why don't you shoot it?
We count those here, ladies and gentlemen. That was amazing. That was my favorite sports event on stream so far. Maybe besides Aaron Vanucci rage quitting Madden 2007. What's going on?
I don't know. I think I'm hitting
releasing.
B too fast or something.
I see. Because you got to do like a wind up in this, right?
Yeah, something. Nice hit, dude. Oh yeah, goalie, you're on fire.
Skinny guy. All right, we just crossed the 10:30 mark. Anyone just joining us, this is Ask a Scientist Gaming, mediocre gameplay, expert level science. Guest today is Dan Hallinan, who's talking about engineering polymers, designer polymers for a bunch of different applications, from batteries to desalinization to, anything he's interested in, nanostructures, controlling those structures. He's happy to answer those questions. Play Ukraine versus Russia next. No, it's too soon. Too soon.
Is that even an option?
It's URS, which is... What is TCH? What is that one? Go over one more. I don't know what that is. The Czech Republic?
Let's do Canada. Yeah, probably.
Yeah. Versus the USSR. A big spooky skeleton is redeemed. Request a factoid.
All right.
So,
well, I already used up another one. Yeah, let's pour a little more. Yeah. Okay. Well, so I already talked about part of this factoid. The DNA is a polymer, but I didn't talk about the other part. Thank you, sir. Which is that DNA is such a large molecule, and because of its alpha helix is such an extended chain that you can see it in an optical microscope, a single molecule. Most polymer molecules are not big enough to see in an optical microscope. But cheers.
Cheers, a big spooky skeleton. Thank you as always for joining us. The names are a fun part of this endeavor.
Yeah, that's cool.
I have to say many interesting things over the course of asking you these questions. Should we do a prediction? Will Dan win this game?
I am playing as Canada, but I would probably still bet no.
You're gonna bet no? We'll see if the audience has more faith in you than you do. Your students, at the very least, in the watch party.
Okay.
Or maybe they're skeptics.
We're gonna go.
Will Dan win this game? I probably shouldn't have put 2 minutes on this. Give me a second. I'm gonna redo this one. Turn points. Will Dan win this game? So we still got to play some NARC after this.
Okay.
We got to close the night.
Okay, but I have to. Well, this is going to be like 21 minutes.
Is it that long?
Yeah, because it's 7-minute quarter. So should we not do that?
Yeah, let's move to NARC.
Okay.
All right, you ready for this?
Yeah, I'm ready.
We're gonna win the war on drugs, ladies and gentlemen. All right, so this is NARC. Have you ever played this before?
No.
There was an arcade version of this, but B is jump, A is shoot.
I'm using this?
Yep.
Okay.
So if you hold B, it squats. If you tap B, it jumps. If you hold A, it shoots. If you tap A, it does rockets. But just press start. You'll figure it out as you go. This game is essentially walk to the right and go through doors. Killing things doesn't do anything for you.
Oh, okay.
Uh-oh. I gotta get my clock up.
So it's like Contra.
All right. There we go.
Do I have a limited number of rockets?
No, you're unlimited bullets, unlimited rockets, and infinite lives. You are just walking right, essentially. And here's your timer if you're interested in how long this takes you.
I'm supposed to do it as fast as I can?
Well, I mean, you don't have to, but I do have a list of how fast every one of my guests beats this game.
There's no way to run, though?
No, this is it. And if you squat, you go slower, so
don't ever squat.
And every time you get shot 4 times, you lose a second. So you avoid bullets as well.
Oh, are you sure you don't run out of rockets?
Nope.
The dog's gonna get me.
Nope. Infinite bullets, infinite rockets, infinite lives. Hamsterlicious is correct. This is the best game in the world. So I played this as a kid, and when I was the guest on the stream, Eugene DePrince was the host. I played this game, and then I started making every guest close the night with this, because why not win the war on drugs every other
The timer's still
night?
going. Come on.
Yeah. No, the clock it's always going to be there.
Do I?
All right.
Can I skip those like transition things?
Nope, those are part of it. Oodles Vomix wants to know, what is the most promising battery producer right now? Looking for some stock tips.
Oh, well, Panasonic is making Tesla's batteries. These are not. These comments cannot be construed as financial advice.
Do not come to Ask a Scientist Gaming for mediocre gameplay, expert level science, and absolute shit stock advice. Or maybe, I don't know.
Yeah.
So Panasonic, they're the go-to in battery production.
LG makes good batteries too.
All right,
you
so
can die?
You have to, well, yeah, but you have infinite lives.
Okay.
So you have to bullet
exit's
these
there.
guys wearing black, and they'll drop a blue card, and then you'll pick it up. So hold A. They'll do bullets, yep.
Oh, there it is.
So that's money. So it'll be... And you want to shoot them when they're close to you for some reason. I don't know how this game works.
Can I kill this dog?
We have a heavy one to close the night after a few glasses of wine while playing NARC. But you do have a philosophy degree, so this is okay. Consciousness? Yeah, there we go. I saw NES, I'm like, NES? First time chat, by the way, so dropping a bomb early.
I picked up the blue safeguard.
Famous Dr.
There we
Neil
go.
Tyson question.
Okay.
How do you reconcile your religious life with your scientific research? I.e., is there a supreme being based on your polymer research?
Yeah, I love that question. I actually have no conflict between believing in God and being a scientist, and in fact, I feel that they enrich each other. Those two parts of my life, and ooh, I'm getting whooped here. So what do I mean by that? I'll give you some examples. The world is like so amazing and beautiful and complex.
Jump into that car by tapping B. Yep, there you go.
Sweet.
But what sucks?
Oh,
Yeah. Unless you memorize the pattern with the car, that happens every single time. I apologize for the taste of speed that you had there, and then absolutely pulled the rug out from under you.
so it really like. Oh wow! It's like a ninja. Did those guys die?
Yeah. For some reason, they don't explode. They stay intact when you hit them with a rocket.
You can't catch me. Yeah, so I mean, like, just the beauty of the world makes me, made me want to. Oh, I have to jump over it, I guess. Huh?
Yeah.
Want to study it and understand how it works. You know, so I don't feel that I like need to reconcile them. They're obviously, like, I don't do my science based on faith, like I do my science based on the scientific method. And I don't live my religious life based on the scientific method, because we talked about it earlier. I took a class on that and basically proved that you can't prove definitively, unquestionably, the existence of God. Ooh.
So the dog you can shoot if you squat shoot. So if you hold A and B, hold them both down. Yep, there you go.
He got me anyway. He like turned into a puppy.
All right.
This is long level.
Yeah, no, without the card, it's pretty slow.
Yeah, if I wasn't playing a video game, I'm sure I could go into much deeper.
So if you stay on the bottom, it gets you pretty far, but then there's going to be mines up here.
Oh, those mines.
Yep.
Well,
Yeah.
I just hope I'm not the slowest ever.
I'm not going to tell you the times until after you're done, just to not put any undue pressure on you. But no worries. A big spooky skeleton. I've been doing some very low quality sprite art, and I've got to say, NARC's walk animation looks suave as heck. I think Justin called it a saunter. The saunter of this DE age.
I'm getting tired of holding the right button down.
You'll come across a car again and just stay on the bottom, and you can go all the way to the end. So there's a pattern you have to memorize on this. No, you're at the end, so it's okay.
Jump. Come on, dude.
It's a heavy question, reconciling religion with scientific research, and we went all epistemological tonight. Yeah, which is fun.
There was a neat priest at my church. He's moved to another church since, but who he had done a lot of thinking about that, and even gave some presentations on it, on how science and religion can enrich each other.
That's fun. Clowns with knives.
Clowns. Is there anything scarier than clowns with knives?
This is why we can't win the war on drugs.
Just jump.
So I'll give you a hint on a door. I give it to everyone. It's the last door that you want to go in. So one is useless.
Oh, it slows me down?
Yep. So there's a card you need to get. Oh, oops. You're back.
Oh, no.
So you got to go all the way to the right.
No way.
Yeah, no, it's terrible. So you can't press up after you've went through the door. All right. I'll change directions with question a little bit, because we always want to know this answer. If you had unlimited resources and no moral qualms... Going to be related to NARC. Unlimited resources, no moral qualms. What would you do with it?
If I had okay. What would I do with it? Okay, yeah, so...
What experiment would you conduct? What research would you do? So that door, the farthest one on the right.
And then in here?
Yep. Well, you're going to go to the end, and there'll be a card that you got to pick up. And you're going to go out the door, and it's going to do the same thing where it'll walk you in if you... These guys can absorb some bullets.
You said it, and I still did it.
Yeah. No worries.
That's how bad I am. I would... So I gave this some thought, because I had this question ahead of time. And I went all... it kind of took me to my childhood. Or it didn't take me to my childhood, but it made me think like a child. And my answer is I would drill to the center of the earth. Because nobody knows what's there, for sure.
Yeah, and the goal would be to learn just what happens.
Why do we have a magnetic field, and why does it shift every, 100,000 years or million years, whatever the number is?
There's an awesome physics calculation. I can't remember the exact numbers, but if you drilled a hole to the center of the earth, it would take you 42 minutes to fall or something like that, regardless of what distance you fall from, because the acceleration would be different.
Oh,
Zero friction or something like that. A physicist, ninja physics, where are you on this one? There's something like, I think it's the number's 42 minutes. But you could do a lot with that. A lot of our nuclear power comes from within our core. That's why the temperature's maintained so long. It's because nuclear decay and things like that. But also geothermal power, you could tap into that directly.
Yep.
Drill through. Yeah. No, we were all that kid on the playground trying to drill as deep as we could.
Come on, let's dig let's dig to China.
So not battery anyway.
No.
Just dig to the core, see what happens.
I wonder if I can jump in those cars. Has anybody ever jumped in one of those?
No, they just run you over. Oh, those guys shoot hypodermic needles, by the way.
That's why I keep falling down.
Yep. All right, anyone, we have about 12 minutes left in the stream, or however long it takes Dan to beat this game. If you have any questions about Polymer engineering, ion transported batteries. Any questions? I gotta change the name of the stream. We're gonna put it to NARC and retro.
Oh, I'm not very good at this.
If you were to make 100% off-grid compound,
Yeah.
how would you make it? Oh, like a compound, like a.
Yeah. Like a place where you would have lots of guns inside.
Man, I can't think of another word to describe compound. Maybe that is the word. Off the grid, how would you do it?
Well, what is a how would I do it? Well, I mean, solar panels.
Yeah, solar panels, collection of batteries.
I've always
3D printer would be useful.
yeah. I've always wanted to. I guess it would depend to some extent on where it is. If it's a place with a lot of rain, I would love to like put little tiny turbines in all my downspouts. I think that would be super cool. I don't know if it would actually work, but to like basically every time it rains, you.
Yeah. So water collection, power. What else do you need? Waste management strategy.
You need food, right? You
Food.
need. So can the compound have like an outdoor area?
I mean, all the criteria here is 100% off the grid. How would you make it?
Oh my gosh, I'm getting housed.
And so this question is related to my like. I didn't have these questions when I was actually the guest on the stream, but like, unlimited resources, what experiment would you do? I would love to build a city with the most advanced, like, self-sustaining technology that exists right now. Like, not even develop new technology, just use the things we have already. Solar cells and batteries and, thermoelectrics, nuclear, all of it. And just try to make a self-sustaining city, right? And you could say, I'm going to make a college. Oh, you got to
get a gold card, huh?
You have to shoot the guy in a wheelchair.
Oh.
So he's not here yet. You're going to shoot a rocket at the guy that's going to show up after you kill the 2 brown guys and then 2 blue guys, and then the wheelchair guy will show up. There he is.
Sweet.
So you got to shoot a rocket at him. So tapping A.
I'm tapping A. There we go.
There you go.
But he's gone now.
But I would love to like build a city with every design criteria that's known now and see how efficient it could be, how self-sustaining. Like, can it be isolated? Does it need external things coming in? We're talking about vertical farms and, hydroponic growth and everything that we know about sustainability. What kind of city could we build if we had unlimited money to do it now?
There he is. I'm not getting rocket.
14 minutes in, so try it again.
Maybe I'm pressing it too long. Oh, it's a really quick tap.
Yeah, it's like 4 frames or something like that. Nice. So he's going to inchworm to the right.
Oh, no.
Then you're going to do that 2 more times.
Oh my gosh. I don't know if I can make it. Why can't I? These dogs are eating me. Yes.
All right, there you go. So he's going to drop a gold card. And then, ladies and gentlemen, if you have not seen this boss before, it is time to get to Mr. Big.
Good thing you gave me unlimited lives.
Yes, the new futuristic city in Africa made by Akon. Close. I mean, I don't know how optimized his is going to be, but like if you had unlimited money, imagine like every single house being absolutely energy efficient, every appliance, every solar cell. So this guy, the secret on him is you have to jump and rocket him in the hat the first time.
Okay.
And if you go to the top of the screen, he won't hit you. Man,
He's eating me.
Oodles of Omics has requested a factoid.
Okay. A factoid. Is it supposed to be scientific or
no? It can be.
It doesn't
anything.
matter.
We have no rules. They just want to know a factoid.
Okay. All right. Let's see. All right. Well, You can
So
get,
you have a lot of room to run.
Oh,
So I
okay.
would stay at the top, get a good distance away, turn back, jump, and rocket it.
if you oh my gosh.
It's non-trivial. It's a tap of B and then a tap of A while you're in the air.
I guess I'm hitting A for too long.
Oh, there you go.
My factoid, you can actually
Ooh, that was
get an
close.
NES system without the gun if you win it from a fundraiser at your elementary school.
Oh, your first NES
Yeah.
in your possession,
Yeah,
but without the gun.
that's right. And without the duck, whatever, duck hunt.
Duck hunt, yeah. It depends which version
Can't
you
get
got.
past him. Oh my gosh. I can't get away from him.
Jumping?
Oh,
Jump left, yeah.
oh, if you shoot
Then I
him,
get a
too.
good distance away. Yep.
Okay, here
Jump
we go.
rocket the hat. A little bit earlier. Oh, there it is. Okay, now just rocket him in the face. All right, now you're going to run around and shoot bullets at his spine. So yeah, I basically run away. You can't do it from the top of the screen for some reason. You have to be lower, but he doesn't shoot stuff anymore, so it's not bad. Oh, 2 vertebrae down. Oh, man, I'm enthralled. And it's really weird. It's like you have to just keep repositioning yourself up and down on this
How are you
y-axis.
supposed to get by him?
Just
If you want to
jump.
go the other way. Oh, jump.
Yep. Just reposition, turn around, and shoot. It has to do with how low his head is and all sorts of stuff. Anyway, we got about 5 minutes left, ladies and gentlemen. This creature is the best designed final boss. Yes, I think that's a universally factually true statement. So can we know anything for sure? Yes, that is what we can know for sure. Full circles, ladies. Full circle, ladies and gentlemen. All right. So if anyone has suggestions on who we should raid after the stream, please throw them in chat, and we're happy to. Yeah, question mark is the way to go. All right. And you got him. It's just get a good distance, go down. Yeah, that's what I do. Just get away from him a little bit. Move up and down on the y-axis. Maybe pick a line.
Pick a line.
Yeah.
You don't think I need a jump, though? I don't need to hit his head?
Nope, it's like hitting his vertebrae, but you have to be a specific position and turn back, and your bullets have to be firing at the... There you go. There's another one. So this third one is going to be one of the harder ones. No, go!
That's it?
Yep, that's it. All right, suggestions of who we should raid, because Dan's about to beat NARC and win the war on drugs. It is an exciting time to be alive, ladies and gentlemen.
Guess I should have beat him at the other end. Come on, I gotta be under 20. Come on,
Jump at the same velocity as when you run, you win. So there's one more level. Close it out right here. Oh, Lord of Giraffes redeemed, take a drink. Cheers, the last sip of the night. We are about to beat NARC, ladies and gentlemen. And I can see where you sit on this. Under 20 minutes. Congratulations. I need to look at
You
where-
helped me a lot.
I help everyone a lot. That does not mean they're going to beat it. So here's my master list of guest times. I added a little extra time on the end because we started a little bit late. I can give
Okay.
you an actual time later, but
All right.
where does that put you?
Just not last.
1959. That puts you in third place.
Third
And
place.
Rob Lazenby and Justin Kennemer.
You helped me a lot.
To be fair, Justin played it twice. I help everyone a lot. Sometimes I even play for people. So, congratulations.
Thank you.
You beat NARC in under 20 minutes. Next time, it'll be even easier because you know how to beat the boss. But yeah, put your initials in. If you
Right.
put ass in, it doubles your score. It's totally up to you. All right. Oh my God. Omics of new. Oodles of Omics has also redeemed Take a Drink. So,
All right.
all right.
I've got a little sip at
Cheers,
the
ladies
bottom.
and gentlemen.
Cheers.
All right, suggestions for who we should raid. If anyone has them, throw them in now. If not, it's been a pleasure. It's always a pleasure to have you guys. Your questions are amazing. It really is a fun time for us to answer them and think about them and discuss them. So we really appreciate you showing up to stream and being involved in this, because we really enjoy our time here. 2 weeks from now, we will have Chris Mills, who's a computer scientist that studies AI and machine learning. So that should be fun. So he's on the much more of computer science end of the spectrum, so that should be a really fun discussion in terms of applications. He's actually CEO of a company that actually applies that to real problems, which will be a lot of fun. But Dan, thank you again for joining me tonight. It was a lot of fun discussing these things. We learned a bunch along the way, particularly that you had a philosophy degree, as well as you enjoy surfing, and a whole bunch about batteries and polymer design and things like that. So any parting words for the audience?
Yeah, practice.
Practice.
Yeah, practice. Okay, yeah. Let me give a serious parting word to the audience.
All right.
Pursue what you're passionate about and work hard to make a difference in whatever that is.
All right. Dan.
And thanks for watching me, especially those who stayed through the painful Battletoads portion.
I think you didn't quite make it as far as David Collins, but I think you made it the second farthest out of everyone. So congratulations. Again, thank you all for swinging by. It's been a pleasure. We'll see you in 2 weeks. Computer scientist Chris Mills will be on. Until then, we'll see you guys later.